So good morning and welcome to the second day of the mid-year meeting of the Indian Academy of Sciences. We start the day with a special lecture, and it is my pleasure to invite Professor Kalyan Sinha to chair the session.
It's a pleasure. So, good morning to all of you. And today, the proceedings will be started by Professor Maithili Ramaswamy, and she is an expert in differential equations, as the title also says. She did a PhD in Paris and was elected to the fellowship in 2007. She was in TIFR CAM in Bangalore earlier. Now she is at ICTS in Bangalore. Now, before I hand over the floor, I thought I will make a short remark of historical nature. I cannot help but mention one of the historical points in this context, namely Newton, Isaac Newton that is, the great polymath, did not use his own discovery, arguably, of differential equation techniques to solve the famous Kepler problem, but instead he used geometric methods. In his Principia, he did not use a spot of calculus. This I mention just to bring forth in front of you the principle of unity of mathematics. Now I would invite Professor Ramaswamy to give her talk, Differential Equations Techniques.
Yeah. Good morning, everybody. Many thanks to the Academy for inviting me to give this talk. And thank you, Professor Kalyan Sinha, for your kind introduction and introducing Newton's approach to the differential equation. It's very true. That is a point I also wanted to say. So thank you for giving it in the introduction. So also I have to thank yesterday's speakers who paved the way for differential equations. Amit Agarwal had already introduced Navier-Stokes equation. I'm thankful to him. And also Harsha Prahalad, he introduced linear differential equations, of course from a different angle. That is precisely my point. You can arrive at differential equation from any of the roads. And finally, each one approaches in a different way. And one would have different perspective, different questions, and different set of tools. But if there is a talk between across the disciplines, that will profoundly improve the research level in all the subjects. So that is the reason why I have made it a very general talk for almost 3/4 of the talk, so that it will be accessible to all the audience. And later on, I just touch upon the special topics what our group is working in the recent years. Okay, so I have divided my talk like this. I start with a small preamble, and since I'm an analyst, I have to tell you what is an analyst viewpoint. And then I come to fluid models, where of course Navier-Stokes will appear, and some control questions which our group is working currently in the past few years. And I talk about, first it will be for ordinary differential equation, and then I go to the control of partial differential equation. So I have to confess, to borrow the pun from our colleague Rajaram Nityananda, I'm going to be very partial to partial differential equations. So although I say differential equations, it's mostly partial differential equation. So let us start with the mathematical models. Of course, it comes in every physical phenomenon like melting of ice, radioactive decay, spring motion, heat conduction, many, and currently it is the stock fluctuation and the spread of infectious diseases. So anything, it's many of them are modeled by differential equations. And what we do is formulate it as a mathematical model using approximations or assumptions based on experiments or observations or physical laws. And then once the equation is written down, you have to solve it analytically, numerically, or whatever method you can think of, and come back and interpret the mathematical results in the context of the phenomenon. Now, why do we do it? We want to understand the phenomenon better, and also we want to make predictions. How the disease, COVID time, you saw there was an explosion of COVID models. We want to predict how it spreads, how we can control, and how much vaccines to be given to which population. These are all very important, the control and prediction using various parameters. So of course I come to Newton, who is the father of applied maths in my view. So his laws of motion, even now it helps us to understand the motion of bodies. So I briefly recall his period when he was 1643 to 1727, and the laws are still going strong. Even the Navier-Stokes we derive from Newton's law, F equal to ma. So, and after Newton, many of the other phenomena also started getting models with differential equations. Came the conduction of heat, of course Fourier we would have heard of, diffusion of chemicals, so that went to heat equation, and which is of parabolic type, I will come back later, and vibration of string and vibration of membranes. These all lead to wave equation, which is of hyperbolic type. And the potential flow, which it goes by the name of Laplace, who worked extensively on this, or Poisson equation, these are of elliptic type. These are the most important linear equations, and they are well studied obviously over the centuries. More important is there are many important nonlinear equations. It's a zoo of nonlinear equations. And some of the most popular ones are Eikonel equation, minimal surface equation, Monge-Ampere equation. And if you go to fluid models, there are plenty of equations. The Euler gave one, Navier-Stokes is one, Korteweg-de Vries is another one, Benjamin Bonan, several models, and many refinements we saw in the talk of Amit Agarwal, how you can refine it in a different way so that you capture different aspects of it, what was not possible with the Navier-Stokes. Now, of course, this has many applications in atmospheric sciences, oceanic sciences, aeronautics, blood flow, and the flow through the lungs. And so everywhere the fluid models have become very important for studying. Another important point is the unity of mathematics. What Professor Kalyan Sinha mentioned, I want to stress here. The PDE has roots in physics. Both these subjects had no clear boundaries in the days of D'Alembert, Euler, Poisson, and Laplace. They all studied physics and maths together and modeled the way they could think. And Riemann used PDE in solving problems in complex analysis. We are all familiar with Cauchy-Riemann equations. And of course, in geometry and topology, you come to Laplace-Beltrami, Dirac operator on manifolds, Hodge systems, Young-Mill equations, Seeberg-Witten equations. They all arise as very useful tools in topology and symplectic geometry. And recently I learned even algebraic geometry, the integrable systems seem to have deep applications in algebraic geometry. The spectral theory of Laplace-Beltrami operators and scattering theory of wave equations seem to have connections with the study of automorphic forms in number theory. This was also very interesting. I learned it from a very interesting review of Kleiner-Mann. I'll give the reference at the end. So as you see, you may come to differential equations from many of the directions. from as an applied mathematicians or a physicist or a chemist or a geometer or an analyst. So there are several viewpoints. So I am going to take an analyst viewpoint. Then I want to say what an analyst does, what are the questions and how do we proceed, what are the tools. So this is what I want to briefly explain. So first of all, we worry about well-posed problems. So once a PD is given, either it has a solution, is the solution unique, and is it sort of continuous. What I mean is, if I change the data slightly, that should result in a correspondingly small change in the solution. If all these three are true, then I say well-posed problem is well-posed, because it's the PDE plus the side condition, auxiliary condition, something in the form of boundary conditions, initial conditions, etc. It was coined by Hadamard, a French mathematician. He introduced this, and he also introduced the classification of second order PDEs, which I mentioned in the beginning, elliptic, parabolic, hyperbolic. We'll need it later on. So for the three important linear equations, there is a well-developed existence theory. Now the question is, what happens for the nonlinear equation? In the nonlinear equation, there are many questions still remaining. And let me go to, but before going to that nonlinear equation and the questions, I have to tell you what we mean by solution. Usually what we understand is a solution has as many, a function, it should have as many derivatives as required in the differential equation. So if you have two derivatives appearing, you may demand a C2 function. This is very natural, but the classical solution concept is too rigid, and very quickly we realize it is not possible to do many things with classical solutions. So it became natural to generalize it. So a generalized solution or a weak solution, in contrast, we don't demand that the PDE satisfies point-wise everywhere. Instead, it satisfies is in an averaged sense or in an integral sense. I'll give an example. When multiplied by a smooth test function, this way we can demand much less on the solution. So we don't have to live in the small subset of very smooth functions. We can enlarge the class of solutions. I'll tell you what are the advantages. The theory of distributions introduced by Schwartz provides a satisfactory framework to search for generalized solutions. So the popular method is you solve the original problem in a generalized sense, because that may be much more easier and many other tools are available, and then you independently obtain regularity estimates to conclude that the generalized or weak solution is indeed a classical one. So this is the usual path one follows. So now I want to convince you that you do need the concept of generalized solution, because D'Alembert worked on the wave equation and he gave a formula for the solution when you are given the initial value of the function and initial value of the derivative. Now this formula involves only those two functions and an integral of the one function. So you see that the formula will make sense even if the function is discontinuous. So it became a big controversy at that time. How can a solution of a second order PDE be discontinuous? It was shocking. So there was a lot of controversy at that time, but it was resolved much later. So similarly, if you go to scalar conservation laws or typically in transport equation, the so-called characteristic, the solution remains constant along the characteristic. But the problem is the characteristics will intersect, and that will lead to multi-valued solutions. Then how do we interpret this multi-valued solution? So that becomes a shock. So this is inherent in the equation, and this will have to be interpreted outside the realm of classical solution. So that is not possible. And viscosity solution, the concept introduced by Pierre-Louis Lyons and his collaborators, This is a very important concept. This makes it much easier to handle even degenerate elliptic equations and also passage to limits. This is a very important thing for an analyst, because we will have a sequence of solutions and perturbed, and then we want to pass to the limit, and the limit may escape your class of solutions. Then we don't gain much. So we would like to the solution concept to be stable under passage to limits. But then we have opened the floodgates, so there will be just too many generalized solutions. That is the inconvenience we have to live with. So it becomes very crucial to work in suitable function spaces, and then we have to pick the physically relevant one. So that is dictated by the model and the problem. So that will be suitable additional conditions like entropy conditions, etc. will have to be added. And so this is the theory existence of weak solutions. That is one possible direction. So let me go to an example just to give you an idea how do we define a weak formulation. Suppose U is a classical solution of Laplace equation. I assume that you are familiar with this notation Laplacian. Laplacian is the sum of all the second order derivatives of U. So like d2u by dxi dxj. So my omega is open connected domain in Rn, and d omega is the boundary, smooth boundary of that domain, and we are given the function f, which is also assumed to be smooth, and I make u equal to 0 on the boundary. Then we say that if it is suppose you start with a classical solution, I can always multiply this by a smooth function. Now d omega is a typical notation to denote this phi is a very smooth function with compact support. That is, it remains non-zero only in a compact subset of omega. Outside it vanishes. So if I multiply, see the left hand side and integrate it over omega, left hand side has become f phi. But what happens to the right hand side? I can integrate by parts so that one gradient falls on the phi. Gradient u dot gradient phi. This is a n vector, this is an n vector, we are taking a scalar product. So now if you look at the integral, I just want this function to be integrable. We don't need the function to be smooth C1 or C2. So this makes sense even for u just in L2 with the gradient of u in L2 and f is in L2. So this leads to the introduction of spaces of L2 functions having weak derivatives in L2, because obviously L2 functions I cannot talk about derivatives at every point. So we have to introduce some notion of weak derivative again through, in an average sense, through integrals. Then that is the correct solution space we have to work with. And these are Hilbert spaces, and so they are complete, and so they have all the important good properties that you want for a solution space. These are the famous Sobolev spaces. So now you see how to define the weak solution. So we'll use the Sobolev space because the boundary condition is 0. That is why H1 is the analog of C1, but on the Lebesgue functions side. So if you start with C0, you go to C1. If you start with L2, which is like H0, then you go to H1. That means this first derivative is also in L2. And this bottom 0 indicates the function vanishes on the boundary. So it's just a notation. So we call it a weak solution if it satisfies Laplacian u dot Laplacian, gradient u dot gradient v is equal to Fv. This is the gradient du by dxi blah 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 du by dxn, the gradient vector. This motivates the introduction of a bilinear form because the left hand side is bilinear in u and v, and once you have a bilinear form in a Hilbert space, you have very powerful functional analytic tools to get the existence of the weak solution. This is what I mentioned, that getting existence could be very simplified if you go to the weak solution setup. Then you can independently work on the regularity of the solution by getting more estimates and the technical details. Now from, let me come to the fluid models, just to, yeah, I have, so again starting from Newton's law, F equal to ma, so we will come to conservation of mass and conservation of momentum. A description of the fluid motion can be derived. So the velocity, imagine this is happening in R3. So the velocity vector is going to have three components in x, y and z, and the pressure P will be a scalar. And so the incompressible fluid, after the derivation which you saw in yesterday's talk, you come to this kind of equation. So this is du by dt, and this is a difficult nonlinear term which makes Navier-Stokes fascinating. And this is gradient of P, the pressure, and nu is the viscosity coefficient. Now if this term drops out, nu is 0, then we end up with the Euler equation, and divergence of u equal to 0, with this represents the incompressibility condition of the fluid. Now this has been a nagging question for more than 1.5 centuries. So let us look at the authors of this equation. So Claude Louis Navier was a French engineer in 1785 to 1836. He proposed this, and Sir George Stokes, from British mathematician, 1819 to 1903. He proposed actually the Stokes equation, and then also he worked on this. Recently in 5 years back, Stokes at 200. The conference was held in UK by Royal Society, and many of his work and contributions, and of course the Navier-Stokes equation, the current setup, everything was discussed there. So let me go to the solutions of Navier-Stokes equation. So we would like to probably go through the weak solution, and Leray, a French mathematician, in 1933, he proved a global weak solution. Global means for all time. That is what ideal we would like. Of the Navier-Stokes equations using a compactness method. But that was not enough, because the uniqueness of this solution was not known. Even today, in 3 dimension, which is more relevant to us, it is not known. Whereas the existence of a unique smooth solution, but you have some additional hypothesis. Either data must be small or the time interval must be small. Then you have unique smooth solution. This is known. This has been known. But we don't know whether this smooth solution, how far I can extend this smooth solution. If I extend it globally, or does it develop singularities? So that is where the Clay Millennium Prize problem was announced. That is to decide if there exists a smooth global solution for reasonable initial conditions. So I have hidden here all the technical descriptions of the initial condition, or if there exist certain initial conditions for which the solution blows up, or in short, do you have a unique smooth or blow up? We don't know. So you can refer to Terence Tao, has lot of blogs. He writes very nice blogs. One of them is on Navier-Stokes. What is new? So he keeps updating that. So it's interesting to see his viewpoint in that. So I wanted to say a word about this Clay Millennium Prize, because in the 17th, 18th centuries, it was the prizes were announced by various science academies in Germany, France, and Russia, St. Petersburg. And the prize was announced, and these questions really shaped the direction of mathematical research. And in 1900, Hilbert announced 23 open problems, and they really determined the direction of mathematical research in the 20th century. Keeping the same tradition, Mathematics Institute, Clay Mathematics Institute announced in 2000 7 problems of this type, out of which 6 are still outstanding, and one Poincaré conjecture was solved recently. So that is a bit of a history. So let me go to more technical work which our group is doing. So I come to control of differential equations now. What are the questions in this field? So we want to know whether we can control the trajectories of a differential equation to reach a desired target. Can we control it in an optimal manner? Can we use the control to stabilize the system if it is unstable? Actually, these are all the questions which became very popular during the Second World War. Although the war is bad, but it stimulated so much of research in control theory both in Russia and US. So for ODEs, these are well studied. Some of these techniques have been extended suitably for linear PDEs. It's easy to extend, and some non-linear too. So this is what I'll just briefly touch upon. I'm going to only concentrate on the stability aspect, not on the controllability and other things. So suppose I have a linear differential equation like yesterday's talk, z prime equal to a zt, but except that it's a system of ODEs. Z is a vector in Rn, A is a n by n matrix. So we know the solution is given by e power at and the acting on the vector z0. So this is a trajectory evolving in Rn. And we know very well how to write e power at because I can simply write a series solution I plus a plus a square by 2 etc. So we know how to write the solution. And then we can also, sorry, I went somewhere, yeah. So solutions starting near the equilibrium point will tend to 0 exponentially as t tends to infinity if, see the spectrum of A I have denoted by sigma of A. A has the matrix A has n eigenvalues. If all the eigenvalues have real part strictly negative, I know the solution trajectories will decay to 0. Now if not, what can we do? We would like to stabilize the system. So we stabilize the system by adding a control term to bring the trajectories to 0. So that is how do we do the stabilization of ordinary differential equations in Rn. Z prime equal to a is zt plus b is given. B is the control term which you know already. You may be controlling through certain quantities. So the b is given, a is given, and this is the initial vector. Let's say a is a n by n matrix and b is n by m matrix. The control u is to be determined. We don't know the control. How do we find it? Now in the ODE setup, it has been in the quite well understood. We can find a control u steering the solution to 0. Now we can even find it in the feedback form. What does it mean, feedback? For every instant, the control should depend on the position of the solution. That is why we want the control to be a k times zt. K is some linear operator. K is from Rn to Rm, another matrix. And we know that how to the k can be determined through Riccati equations, and that is well understood, the theory. And even algorithms exist, and we can put it in the computer and compute it also. Now this system, if I put in the u as kz, I have shifted the dynamics from A to A plus bk. So the advantage now is the A did not have all the eigenvalues on the negative part of the complex plane, but A plus bk, the real part of all the eigenvalues of A plus bk, we can push it to the negative side of the complex plane. So that way this system will be stabilized. The choice of such a k is well understood for ODEs. So now what happens for PDEs? So we want to extend these techniques to PDEs. So we would like to view the PDE system as ODEs, evolving not in Rn, finite dimensional Euclidean space, but infinite dimensional function spaces, usually Sobolev spaces, which I mentioned. These are the spaces for the solution, considering only the spatial variables. The analysis in Rn is now replaced by analysis in Hilbert or Banach spaces. If you want to go to LP setup, it will be just Banach spaces. The steady states are the solutions of the stationary PDE. Now we study the spectrum of the linearized operator around the steady states, and hopefully we can construct a feedback control, or at least we can prove the existence of a feedback control, and you can even go to the nonlinear equation and locally stabilize around the steady state. This is the template, but it doesn't work for every PDE, but some of the parabolic PDEs and some other we can. So that is what I want to indicate in the remaining time. So the heat equation, let us take the simplest heat equation. This is a prototype of a parabolic equation, as I mentioned. So the function y equal to yxt satisfies, yt is the time derivative of y minus this is Laplacian of y, the sum of all second derivatives of y is equal to f. These are all functions of x and t, x from omega and t coming from 0 to t, capital T. So yxt we will make it 0 on the boundary, for example, and the initial condition yx0 is given to be y naught of x in the whole domain omega. Now our aim is to write it as an operator equation. So we can call it as dut by dt is equal to a of ut. Now the x is hidden here. So I have to understand what is this operator a doing. A is the Laplacian. Now earlier our A was n by n matrix. Now it has become an unbounded operator. Although I live in L2 of 0, 1, the Laplacian is obviously not defined on the entire L2. It will be defined only on a subspace where the second weak derivatives will exist. That is like H2. H2 of 0, 1 intersection H1 0, sorry, I should have taken omega, I have replaced omega by 0, 1. So I have to take omega as 0, 1 here. It is the spatial domain. So this is the spatial domain for the operator A. This is the unbounded operator. Now I go to the, how about existence? In the ODE case, we simply wrote e power at, and here can I do the something similar? But I can't write e power at because A is unbounded. So we have to appeal to the C0 semigroup theory to get a solution operator St on Z. So this solution operator is something like e power at, but we have to interpret it suitably in the infinite dimensional space. And then the powerful semigroup theory tells you for every u naught in Z, there is a unique solution in this space. What does it mean? For each t, I have a function of x sitting in a function space Z. That could be a Sobolev space. So using the spectral analysis of A, but A is now infinite dimensional operator, I have to understand the spectrum of A, and one constructs a feedback operator to stabilize the equation. This idea works for linear heat equation and also for Stokes equation, and also for nonlinear incompressible Navier-Stokes, as I mentioned, locally around steady state or even a periodic solution. This is what we had tested. But these are all PDEs of parabolic type. Suppose you have a PDE of mixed type. See, hyperbolic type is more difficult for control problems, and we studied the compressible fluid. It's a similar to the Navier-Stokes what I showed. Now the density is not a constant, so incompressibility condition is dropped, but we have we have an equation how rho evolves. Rho is the density, velocity is u. So this is somewhat like a transport equation after linearization, and this will be like the heat equation. So the problem is now the transport equation is of hyperbolic type, whereas the heat equation is of parabolic type, and they both have different behavior under control aspects. So we linearize, so it's not clear when I linearize around one steady state, easiest is constant steady state. Density has to be positive, so rho s is positive. Now velocity may be 0 or may not be 0, so I consider two cases. Vs is 0 or Vs is positive. So we wanted to know when I linearize, it is like a coupled transport equation with heat equation. So what happens to the coupled system? Does it mimic a hyperbolic type transport equation, or does it mimic a parabolic type heat equation? So that when you look at the spectrum, it becomes sort of clear, because the Vs equal to 0, here the complex eigen, it had pairs of complex, finite number of complex eigenvalues and an infinite number of pair of real eigenvalues. Whereas in the other case, I had a hyperbolic portion and a parabolic portion. So let me briefly show you what we computed for a finite number of modes. So what happens is, these are the finite number of complex eigenvalues, and these are the, it goes on, infinite number of the real eigenvalues. Now this is very typical of parabolic problem. Heat op, for example, Laplacian has eigenvalues like this, minus n square, if you are familiar with the spectrum of Laplacian. So the whole operator, by looking at the spectrum, you see it is contained in a sector in the complex plane. So we could guess it must behave like the parabolic type. So I'll show you in contrast what is the spectrum of the other case. That is Vs, the velocity is now positive. So the spectrum does behave like Laplacian, going to infinity, except that it has now become complex, but nevertheless it goes to minus infinity like a parabolic operator. But this one is going up to plus infinity in the imaginary axis and minus infinity in the imaginary axis. So it is no more sectorial operator, and that completely changes the approach what you have to do. So this is just to indicate what the differences, and we use these to stabilize the system. Let me go to all my thanks to my collaborators and financial support in the past few years. Jean-Pierre Rameau from IMT Toulouse, Michael Renardi from Virginia Tech USA, and Praveen Chandrasekhar, my colleague from TIFA-CAM. And these are my former students who are now faculty in IISER Kolkata, TIFA-CAM and IIT Bombay. And for this work, the financial support came from two CEFIPRA projects and IFCAM projects, and also the Airbus chair funds from Airbus, what offered to TIFA-CAM. And a few references. This contains the idea of how you pass from ODE to PDE setup through the semi-group theory I told you. And Brazis and Browder, they had a nice review article, but it's quite old, 1998. Kleinerman gave the very interesting review in geometric and functional analysis in 2000, PDE as a unified subject, where he gives the applications from various fields, that is where I learnt all these applications. I had written one review article. Terence Tao has several blogs. One of them I have mentioned here, Why Global Regularity for Navier-Stokes is Hard, in 2007. Recently he has many more, he has updated that. So this is a good place to stop, and thank you for your attention.
Questions or comments?
Yeah.
I mean, it's Dirichlet problems.
Yes.
It's there along with the Riemann hypothesis.
Riemann hypothesis and Hodge conjecture.
Do you think?
What is happening? This one?
So what's your feeling? Will there be a solution in the foreseeable future for that? Like
I follow Terence Tao. He himself is confused. Sometimes he says there will be a blow up. He was looking for blow up because we know that which of the norms, if it blows up, the solution will blow up. So vorticity, they were trying to estimate the vorticity. So many norms they were trying to. Now he is also looking at can there be possibility of global solution. So it's not very clear. Both sides, there are many related models for which they are able to prove one or the other. But it's still not clear which way it will go.
Hello. Thanks.
Yeah.
Thanks for a very clear talk.
Thank you.
I have a very naive question, not deep and fundamental. But the question I have is that I keep on seeing always that you talked about small deviations around the state. So the solutions when you study, are you able to put a limit on the deviations around the steady state up to which your solutions will be valid? I mean, is that a reasonable question to ask?
Yes, very much. Because when we try to prove the stabilization result, we have to estimate what is the radius around the steady state, how much I can. So, typically around that radius, I'll be able to converge. But it is not to say that is the only possibility. Numerically, we have tested. Even if you go far out of this, the ball which is given by the theory, there is still convergence. So the result is not optimal.
Okay.
But it gives you some estimate of where you will converge.
Okay.
Yeah.
Because since you mentioned this last thing about the global regularity, I mean, that is somehow the connection.
Yeah. Can you extend?
How far can you go?
Yes.
Yeah. Okay. Thanks.
In many of the differential equations, we have what is known as conditionally exact solutions.
Okay.
Is there a general way of detecting that possibility?
Yeah, this is how do you get exact solution is an art. Sometimes we use symmetry, sometimes we use different tools, and then we get the exact solution. But I am not familiar with the conditionally exact solution. So it may be under some hypothesis, probably, I guess. I don't know. Yes.
Yeah, so thanks for a very nice talk. My question is, if we are looking for a similarity solution, is there any restriction on the nature of the equation which will permit a similarity solution?
Yeah, that by looking at the equation, by looking at the different derivatives coming, what are their, like in the, typically go back to heat equation, I have the first time derivative and second space derivative. So you look at the how I can multiply by a scalar parameter lambda. So the t variable I have to multiply by lambda square, because only one lambda will come out, whereas the x I will have to multiply by just lambda. So I guess by looking at these heuristically, one can go for x square by t could be the similarity variable. Then you have to try, does it work? And then, so by looking at the operator, one has to guess and try various things. I don't know whether there are standard tools to guess that or to arrive at that.
Okay, one last question.
So it could be completely layman's question, but forgive me, madam. So, Malik, tools in laser, and they are for controlling the laser field. Actually, you need to optimize the difference, some parameters in the differential equation if you come from the Schrodinger equation. And I saw, and I just got curious that while solving the control parameter, you actually giving a prescription that if it depend that UT versus JT, they depend on linear way.
Yeah.
But in case of this kind of optimization I talked about, the control parameter is non-linear.
Okay. Yeah. It can. The well understood theory is the linear case. Always linear equation, linear connections are easy to find by theory. But there are many works that deal with non-linear relation between Z and U, and that is also possible. One of the important figures who is trying all these things is Jean-Michel Courant. His book on nonlinearity, he has different types of controls. Some of them are nonlinear functions of the Z. So it's possible. I haven't used, but it is very much available.
And the second question is, in somewhere I see that you are working with sub-Hilbert space.
Hilbert spaces.
Hilbert space. It's
Yeah.
not sub-Hilbert space.
What is sub-Hilbert space? Sobolev spaces. Yeah, yeah, yeah. They are also Hilbert spaces.
Okay.
Yeah.
So for that, how much it is necessary to prove the Young-Mill field?
Young-Mill field. Yeah, that depends on the PDE. So the Young-Mill PDE, if it has two derivatives, you may work with H2. If it has, so depending on the equation number of derivatives, spatial derivatives appearing, you can decide your Sobolev space. Yeah. Thank you.
Okay, I think
Yeah.
that ends it, and let us thank the speaker once again.
Thank you.
Thank you very much, Professor Sinha. Now we move on to the next session, where you have another lecture by fellows and associates. And it's my pleasure to invite Professor Anil Gupta to chair the session.
Good morning, everyone. This session, thank you for giving me an opportunity to chair this session. This includes this is a pre-tea break session, includes two important talks. The first one is by Dr. Anjan Burman, and the other one is by Dr. Anand and Sharma. So I invite Dr. Anjan Burman, who will speak on spin texture drive-in magnetization dynamics in engineered magnetic nanostructures. Dr. Burman, please.
Okay, good morning, everyone, and thanks to the Indian Academy of Sciences for inviting me to give this talk. Today I'm going to talk about spin texture-driven magnetization dynamics in engineered magnetic nanostructure. I'm from the S.N. Bose National Center for Basic Sciences in Kolkata. So the world of spintronics has come a long way from this conventional read-write drive and magnetic random access memory to the spin-orbit torque-driven random access memory, magnonics that I will describe today, like magnon transistor and various other components have come up. Terahertz spintronics and ultrafast all optical writing of bits in the femtosecond time scale to picosecond time scale, because the conventional one is still in the nanosecond time scale. So you have to go much faster. and then atomic-based, spin-based logic devices, and so on. So it has come a long way till then. So that requires the magnetization to, sort of be manipulated in a very fast time scale. And so we'll go through the time scales of magnetization dynamics. And here I show from femtosecond to microsecond, like 10 to the minus 15 to 10 to the minus 6 seconds. And the most fundamental exchange interaction, Heisenberg exchange interaction, fall in the femtosecond time scale. Spin-orbit coupling comes in the hundreds of femtosecond time scale. And the laser-induced ultrafast demagnetization that I will describe today falls in this time scale. And then also the spin transfer torque and spin-orbit torque, they come in the sort of femtosecond time scale. This is followed by the precession of magnetization, which is not the Larmor precession of a single spin, but the precession of the full collective magnetization, followed by its Gilbert damping, and then magnetic writing, vortex core switching, they fall in this time scale. This is followed by the spin waves, which is the collective dynamics of the spins in the system, and the domain wall motion. So I will talk primarily the laser-induced ultrafast demagnetization and the magnons in this talk today. So the ultrafast demagnetization was first discovered in 1996 when Borpierre and Bigot, they actually shined a femtosecond laser pulse on a nickel film, and they showed that the magnetization was quenched partially or sometimes fully in presence of the exchange interaction and a magnetic field. So that was called ultrafast demagnetization. This was followed by the recovery. And they came up with a 3-temperature model where the electron spin and the lattice system come into non-equilibrium with each other and they interact with each other. And you can define temperatures corresponding to the 3 systems, which rises and decays in their own time scale. And you can see here the electron temperature rises first, followed by the spin temperature, and the lattice temperature is growing much slower. So there have been classes of thoughts of describing this, and the debate is still ongoing. And the first one was the spin flip scattering, which was first thought to be a phonon-mediated Elliott-Yaffe type spin flip scattering, but later on electron magnon, Coulomb exchange, and even relativistic photon-induced spin flip scattering have been considered. And then later in 2010, a new transport process-based mechanism came up, where the super diffusive spin transport, which is governed by these laser-excited hot electrons to play a crucial role in the ultrafast demagnetization through this spin-dependent transport. And here you can see that this mean square displacement is proportional to the t to the power gamma, where gamma corresponds to 2 is the ballistic transport, which occurs in the shorter time scale, and 1 is in the diffusive transport that occurs in the longer time scale. It actually occurs somewhere in between, like gamma is between 1 and 2, and that is why it's called the super diffusive spin transport. And that was given by this paper. And then more recently, optically induced spin transfer effect also thought to be playing a role. Now, considering all these effects, primarily the spin transport effect is coming up to be one of the most dominant effects in the recent times. And there, one can see that if you have a domain wall in the system, then the domains of 2 opposite spins can act as 2 different spin channels. Like this can be the up spin channel and the down spin channel. You can call this the majority and the minority spin channel. And in these 2 papers, it was observed that in comparison to the uniformly magnetized system of similar composition, a much faster demagnetization or accelerated demagnetization occur due to the direct transfer of spin angular momentum between the neighboring domains. So they act as 2 different spin channels, like we said. So what our goal is to see what happens. So they were working only on these stripe domains. We wanted to see what happens to the ultrafast spin dynamics if the domain wall can be tailored over a wide range of pattern. And that's what we did here. So what we did here, we took a cobalt-palladium multilayer. It has a perpendicular magnetic anisotropy, and it also has a demagnetizing field. So just by controlling the magnetic field history, like we have listed here, so we first took the AC demagnetization, and we got this kind of stripe domain with some junctions here. and then we apply a 2 kilohertz radian plane field, and we remove the junctions, and we have perfectly parallel stripe domain, and then we apply a 14 kilohertz out of plane magnetic field. We obtain this labyrinth type of domain, and then we apply a 6 kilohertz out of plane magnetic field, and we obtain this kind of bubble domain, and we refined it further. So we are going from a purely one-dimensional domain structure, a two-dimensional domain structure here, and the Fourier transform of those can be shown here. Here you can see just two spots, like the lowest spots here, and here you start to see a full circular pattern due to this two-dimensional structure. So we want to see what happens when we actually go from or transit from this 1D to 2D domain structure in the ultrafast demagnetization. So we use the time-resolved magneto-optical Carr effect magnetometer. So this is based on a femtosecond pump probe technique using a femtosecond amplifier laser, and it's a two-color measurement. So we use the second harmonic generator, and this is the time delay, and this is the sample here. So you can see the two color. The pump beam is falling as an oblique angle, whereas the probe beam is falling on the sample normally. So we are measuring the polar Carr rotation. So it has a time resolution of 40 femtosecond. Spatial resolution is not important here. It's about 200 micron, and the pulse energy repetition rates are like that. And here we can also access various wavelengths from 250 nanometer to 2200 nanometer. So first we consider the power spectral density of the domain walls. And here you can see that we fit this with the asymmetric Lorentzian equation. And we found out the average wave vector, delta k, the domain wall width. And this is very important, the number of domain walls per 100 micron square. And we can see that as we are going from the linear to the two-dimensional domain, the domain wall junction increases enormously from 100 to about 2000. So this will have a role to play, as I will show here. So we measure the ultrafast spin dynamics in this multilayer. First we measure the sample with no domain, and this is the measurement geometry. And here I see the negative delay followed by a fast, ultrafast demagnetization in femtosecond time scale, followed by the recovery and the precession or the spin wave generation, which is very normal for a thin film. So here we have no domain. We fitted it with a 3-temperature model, and we found that the demagnetization time and the recovery time, they're increasing almost linearly with the pump fluence, and the quenching is also increasing with pump fluence. Fine. Now we go to the domains, and here you are, and you can see here, as soon as I have the stripe domain, in addition to the ultrafast demagnetization, it recovers and it actually crosses the saturation magnetization and it increases. So you are actually generating magnetization by the laser pulse, and this is called the transient magnetic generation or enhancement in the picosecond time scale, and then it slowly recovers. When you go to the labyrinth domain, the demagnetization part actually reduces, but the transient magnetic enhancement remains the same. And as you go to the two-dimensional bubble domain, the demagnetization completely disappears, and you have only the transient magnetic enhancement. So there is a drastic change from a two-step to a single-step spin manipulation in the system, and this remains, sort of consistent with the pump fluence. So if I change the pump fluence, only the magnitude and the time changes, but qualitatively they remain the same. So we try to understand why this is happening by developing a spin transport model, a hand waving model, of course. So we took the domain walls. Let's say we have the stripe domains only, and we are pumping and probing the domain walls. So initially we have two different channels. This is, let's say, the down spin channel and the up spin channel. And we know that there is a direct transfer of spin angular momentum between the domains, and we know that the majority carrier mobility is higher than the minority carrier mobility. So as we are pumping it, this down spins will cross the barrier, the domain wall, go to this orange side, whereas the up spin will cross this and go to this side. And as a result, you will have more down spin here that will cancel the up spin and reduce the magnetization. And similarly, it will reduce the magnetization here, and you'll have a partial demagnetization. However, this occurs in the femtosecond time scale. in the picosecond time scale, the minority carrier from here comes back to here and from here to here. And while doing that, it also brings back some of the additional minority carrier, which was the majority here to here and to here. And as a result, you will have more downspin here and more upspin here. And that will increase the net magnetization in the two domains. And you will have a transient magnetic enhancement in picosecond time scale. And after that, they will again come back to their original position and have magnetization recovery. So that is why you see first the demagnetization, followed by the transient magnetic enhancement, and then the recovery. Now, question is why you have only the transient magnetic enhancement in the case of the bubble domain. That is because in the case of bubble domain, you have a really disordered system, and the net magnetization here is very little, almost negligible, as opposed to here. And as a result, if you have almost no net magnetization, so there will be no demagnetization as well, only the transient magnetic enhancement. And also, we will model it using this three temperature T3 time model. So here tau m is the demagnetization, tau TME is the transient magnetic enhancement, and tau r is the demagnetization. And we plotted them as a function of pump fluence, and they all increases with pump fluence, and they changes with the domain wall sort of pattern. And this is very important. Here you can see both the magnetization quenching and the demagnetization. And this is like the stripe domain, and you can see the quenching and the demag time is much higher. And as you go to a higher domain wall density, you reduces the demagnetization, and here the demagnetization almost becomes zero because the the disorder becomes more. And here also you see that where the transient magnetic enhancement actually shows the opposite trend. That is because you have more number of junctions through which the spin transport can occur. So here we observed a stark variation of the laser-induced magnetization response during transition from 1D to 2D domain configuration, and that demonstrates a transformation from a two-step to a single-step like transient magnetic character, and that can be used for a two-step switching operation in ultrafast spintronic devices. And this paper has just been published. Next, we come to the magnonics. We know that for spin transport, there is a transfer of spin from one place to another, so there will be scattering and all this, so that causes energy. Whereas for spin wave, there is only transfer of energy, there is no transfer of a particle. Of course, there is a quasi-particle associated with it, so spins precess in their own position, and the phase is propagating through the medium in 1D, 2D, and 3D. And based on that, we can develop different kind of artificial magnetic medium or the magnonic crystal, which can give rise to different kind of band structure. And I can show you here some band structure with this one-dimensional array of antidots with band gaps and so on. So magnonics basically deals with this propagating spin wave through periodically modulated magnetic media, which has enormous application in gigahertz to terahertz frequency on-chip data transfer, logic, and various other devices. And here you can see some of the examples here. And the last one is the voltage-controlled magnetic logic, because one of the important characteristics of this is external control on the devices. Whether you can control it, because once the device is made, you cannot control it by changing its structure. You can only control it by the external stimuli like electric field, magnetic field, and so on. So whether we can do that. So here we propose to do voltage-controlled magnetic anisotropy. And here one can use the ultra-thin ferromagnetic and insulator bilayer. And what happens here for a ferromagnet, you have the out-of-plane orbital of ferromagnet, like the 3D Z square, and the 2pz orbital of the oxygen. And they actually, sort of overlap and cause a significant charge transfer from 3D Z square to 2pz orbitals. That gives rise to a sizable perpendicular magnetic anisotropy through spin-orbit coupling. Now, if you apply an electric field in this junction, then the number of electrons in the outer plane 3D orbital of the ferromagnet is changed, as compared to the 2pz, and as a result, there is a change in the perpendicular magnetic anisotropy, and that is known as the voltage controlled magnetic anisotropy. And linearly, you can actually express it as delta Ks, that is the change in anisotropy, as beta times Eg, where Eg is the electric field and beta is the voltage controlled magnetic anisotropy coefficient. And one can actually use this not only to change the anisotropy, but to create different type of spin texture, reconfigurable nanochannels for propagating spin waves. That is something that we will do it here. So this is a voltage control magnetic anisotropy based magnonics. So we developed this system. So this is cobalt iron boron and MgO that gives the PCMA or the PMA, and then we actually build an aluminum oxide, and then on top of that we build an ITO based top electrode, where here the gold is the bottom electrode, and we apply a voltage, a gate here. So basically, this electric field penetrates through this junction, and it actually causes a change in the electron occupation at the 3dz and 2pz orbital of the ferromagnet and the magnesium oxide, giving rise to the VCMA. Now here you can see that this pattern, there is no pattern, this is continuous. So the electric field will continuously penetrate and give rise to an uniform change in the anisotropy. So when we do this Brillouin light scattering measurement, we can see that there is a shift in the peak of the spin wave, as opposed to this dotted line, which is for 0, v equals to 0. So when I apply +4, it shifts on the positive side, and -4 volt, it shifts on the negative side. So you know that the VCMA is working. Now we do further characterization. So this is the magnetization, this is roughness profile, and so on. And here we actually find out, as a function of gate voltage, the change in the anisotropy, and which changes linearly. And from there we found out the coefficient, VCMA coefficient, which is reasonably high. And this is the frequency versus wave vector for this continuous, for this device. So there is a single mode, single spin wave mode, which fits with the Demon-Edgepack geometry. Now we do this. Now what we do is we pattern the ITO electrode. And this the width of this pattern is, so here you can see it is about 200 nanometer. So you have 200 nanometer ITO, and then there's a gap of 200 nanometer, and so on. So when you apply and then connect these all to the bottom gate gold electrode, and when you apply the electric field, only the electric field appears beneath these ITO electrodes, and where there is no ITO, no electric field is there. So you essentially, sort of on demand, you can change the spin texture of this sides as opposed to the remaining sides. So you actually create 2 nanochannels through which the spin waves can propagate. And when you do the Brillouin light scattering measurement of the spin wave, you can clearly see that the single spin wave mode actually splits into 2, and here for another wave vector, and you plot them as a function of wave vector, and you can see that, yes, clearly there are 2 modes with a band gap. Okay, so we actually can open a band gap, and as soon as we switch off the voltage, the electric fields will disappear, it will not matter anymore, and we'll have the single mode. So you can on and off the band gap just by controlling the electric field here. And when we do the numerical calculation by using plane wave method, we see that through channel 1, only the spin wave mode 1 is propagating, whereas through channel 2, spin wave mode 2 is propagating. And there is a mode repulsion due to the magnon-magnon coupling in these 2 channels, which is giving rise to the avoided crossing and the observed magnonic band gap. And this is for another wave vector. And this is the reconfigurability. When I apply a earlier I applied -4 volt, when I apply a +4 volt, I can see the band gap changes from 1.3 gigahertz to about 0.9 gigahertz. So the band gap is reconfigurable, although the behavior is essentially qualitatively the same. So here I show further reconfigurability of the nanochannel. So if I do not apply a voltage, I have a single mode. If I have only the reference coffee B and MgO without any top electrode, I have a single mode, and these are the wave vector dependent frequency. So that gives the reconfigurability of these nanochannels, which gives and these will give rise to the parallel processing of modes through the for classical and also quantum computing, because the magnon-magnon couple hybrid modes, they can coherently propagate through over a long distance on chip and give rise to sort of a quantum computing platform. And that appeared in the media for novel design of magnetic nanochannels, which may cut down cost of transferring electronic signals, also Nature India, and so on. So in summary, I have shown you how different domain walls can cause different types of spin transport and sort of give rise to ultrafast spin manipulation from demagnetization to transient magnetic enhancement. I've also shown that how one can tune the voltage control magnetic anisotropy to give rise to different kind of magnetic nanochannels for spin wave propagation. And this is my group. I thank you very much for this wonderful work, and thank you all for your kind attention.
We can have few questions. We still have few minutes. I forgot to mention Dr. Burman was elected to the as the fellow of the Academy in 2020. So we can have few questions. Yeah, please.
So thank you for nice presentation and sharing your results here. I have one simple question. You have shown 9 domain patterns over there for several samples, like stripe-like and then bubble-like and all. So domain wall thickness you mentioned is between kind of 100 nanometer to 200 nanometer.
Yes, something like that.
So what should be the thickness of that top layer where you have measured this?
You mean the cobalt layer?
Yes.
That is about sort of less than a nanometer.
Thickness is less than 1 nanometer.
The width of the domain wall is 100 nanometer. This is a lateral width.
Okay.
And the thickness that is in the Z direction, that is about a little less than a nanometer.
So does it demagnetization, does it depend on the thickness in any
Yes,
way?
yes. The demagnetizing field depends on the thickness.
Right, right.
And
even
also there is,
yes,
and there is a perpendicular magnetic anisotropy at the interface of cobalt and platinum due to the DD band hybridization.
Yeah. So substrate effect is also there.
Substrate effect is there, but here, because it's a big stack, so it is sort of, the strain effect is relieved.
Relieved at nanometer thickness?
Yeah, within few layers it is relieved. There is very little strain, and that is relieved within few nanometer.
Okay,
yeah.
Thanks.
Any other question? So thank you, Dr. Burman.
Thank you.
The next speaker is Dr. Anand N. Sharma from ISER through Anantpuram. Dr. Sharma was elected as Associate of the Academy in 2023, and he will speak on laser communication through turbulent and turbid atmosphere.
Thank you, Professor Gupta, for the introduction. Good morning, everybody. Thanks to the Academy for giving me this opportunity to speak in front of this audience. So I'll be speaking on the topic laser communication through turbulent and turbid atmosphere. So I'm associated with ISER Thiruvananthapuram in the School of Earth, Environment and Sustainability Sciences. So the work that I'll be showing here involves a lot of atmospheric science research and then connected to some communication and optics. So to introduce you to the subject, light as a form of communication has been in existence since a long time. In the older civilizations itself, they have been using fire and smoke or fire torches to convey information from one place to another. And even in the first half of the century when Alexander Graham Bell came up with the idea of photophone, light was a mode of communication. But it was not until the invention of lasers that light as a mode of communication took center stage. So as of now, there is this technology which is called free space optical communication, or FSO in short, which is an emerging technology where light is used as a communication medium, communication mode, and atmosphere acts as the channel. So it's very simple. It's just like pointing a laser beam from here to there, and in between whatever atmosphere is present acts or regulates the performance of this communication system. So like any system, any communication system, it involves a transmitter, in which in this case it would be a laser beam, a receiver is there which is a photodetector, and the channel here is the atmosphere. So whatever properties or characteristics are there of the atmosphere would be influencing the performance of the system. What are the advantages of the system? It is wireless. There is no need to lay optical fibers or copper cables all the way around. It uses laser source. All the inherent advantages of laser would be reflected on this as well. As of now, we don't have to pay anything to get the system done as of now. And it's very easy to set up, and it is portable as I've shown here. And it brings in with a lot of advantages in the form of high bandwidth and data rates as well. But like two sides of a coin, with all these advantages told, there are a set of disadvantages or demerits as well. So what are they? The first one is atmospheric scattering and absorption. There are gas molecules and particles in the atmosphere which can scatter and absorb light. So this would reduce or regulate the intensity of laser beam reaching the photodetector. So this can influence the performance of the system. This needs line of sight. So we can't go beyond something like 10 kilometers or 20 kilometers as of now because of the inherent curvature of the earth surface, and then there are buildings or trees or all those could act as hindrance to this. The most important aspect here, which I would be highlighting in this talk, is refractive index fluctuations. So we expect this light beam to fall directly onto some surface, but due to turbulence in the atmosphere, the refractive index of the medium would change. So this can influence the system. So I'll be showing how it is done, and the atmospheric scattering and absorption can be seen here. So this is the image of the same location taken at two different environment conditions, one with clear sky, whereas there is not much pollution or particles in the atmosphere, and the same condition but with polluted sky. There is a lot of fog or particles present. So you can see directly here the visibility is largely affected by this polluted sky or the particle scattering and absorption. So the distance up to which the laser beam can propagate will be largely inhibited when you have particles in the atmosphere, or which I refer to here by the turbid medium. And the second part, the refractive index fluctuations, is shown with the help of a demonstration here. It is a video which was captured in our laboratory. So the dotted white circle that you are seeing here is the expected position of the laser beam. So under normal circumstances, we expect the laser beam cross section to be entirely within this dotted white circle. But then we did something. We brought in some noise into the system. We brought in some flames and wind and all those things, which introduce some refractive index fluctuations artificially in the system. So what happens now is, instead of it falling into this dotted white circle, it is seen to dance around this white circle. So imagine this dotted white circle as a photodetector, and you want this laser beam to fall entirely within this, right? So this has happened within a few meters length span. Imagine this in the real atmosphere, and the turbulence is too high. It may also lead to a situation in which the entire laser beam falls out of the detector. What would happen then? You get nothing. There is no signal resulting at the receiver end. So you don't get any signal at all if the atmosphere is really turbulent. So this brings us to another term in the title, laser communication through turbulent medium. So these two aspects are being inspected in this talk. And the phenomenon what is shown here is called beam wander, which is a classic example of what atmospheric turbulence can do to laser propagation. And this naturally leads us to a question. Inhomogeneity in any medium can be a problem in optical wireless communication. So what could be the possible sources of inhomogeneity? One is turbulence, which you can't do anything, it is always there. and the other sources of inhomogeneity have to be inspected, and this leads us to something else, which acts as a source of heterogeneity in the atmosphere, which is called atmospheric aerosols, which are tiny solid or liquid particles suspended in the air. So there would be gas molecules and aerosols present in the atmosphere. Gas molecules are well mixed in the atmosphere, which means there is not much variation in its concentration or properties when you are measuring it from one place or the other. But these particles, aerosols, are not like that. They exhibit a lot of heterogeneities in space, time, and along the vertical axis as well. So if they can influence any variations in refractive index fluctuations, that can have a lot of impact on laser propagation as well. And from the climate change perspective, they hold some significance because these particles can scatter radiation and lead to cooling of the Earth's atmosphere. It can also act in the other way. Some of these particles can absorb solar radiation and heat up the atmosphere. So aerosol particles, based on its chemical properties, can be tagged with heating or cooling the Earth's atmosphere. If any change happens in atmospheric temperature, it can directly affect the Earth's refractive index as well. So this led us to studying these particles in detail. And what are the sources for these particles? This can come from sea sprays, volcanic eruptions, dust storms, and it can also be anthropogenic from fossil fuel burning, like the carbonaceous particles or what we call as soot. So this brings us a connect between climate change and communication. So the second aspect that I will be highlighting here is how to quantify turbulence in the atmosphere. So I will be going with a parameter called structure parameter for the refractive index, which tells in a very simple way what is the difference between refractive index between 2 points or 2 time instances. So throughout this talk I will be referring to this parameter Cn square to mention the strength of turbulence. If Cn square is high, it means turbulence is high. If it is less, the turbulence is less. So similar to aerosols, this Cn square can also be time, altitude, or regional dependency. It can also be there. And these both lead us to something unique or important. The existing models of this refractive index structure parameter, which we see in literature, have all been developed by making use of measurements from higher latitudes, US or Europe or so. So this, if we are applying it over our environment, will not be able to capture the turbulent effects faithfully. So this is because of the large variations in solar irradiance or the presence of clouds or aerosols and due to many other reasons. This calls for more observations in Indian region. We need more observational data. Only then we can say whether the characteristics shown by Cn square is following some pattern or not. Or in other way, to develop a model for Cn square, we need more observational data. This forms the primary motive for my research and the lab that I'm having. And if observational data is required, what type of observational data is required? You need observational data which would cover or satisfy laser propagation along horizontal line, which is like a city to city communication, or along the vertical direction, which is something like satellite to earth communication. So you need measurements which would answer both these questions. This can be done by making use of near surface observations. We make use of sensors installed at the surface carrying round the clock observations. You also have to make use of balloon or LiDAR observations to get the vertical characteristics as well. And these observations should measure both aerosols and turbulence. So that forms the primary research motive from our group. These are all set of measurements that are being carried out from our lab or as part of collaborations that we are having. We make use of surface measurements. In IISER Trivandrum, we have set up a lab which measures atmospheric aerosols round the clock and which would give us some optical and physical properties. And then we have some tower mounted sensors. This is part of a good collaboration between IISc, and in IISER also we are soon going to have this facility, which is an eddy covariance tower. This gives us a measure of atmospheric turbulence and meteorology, which is essential in studying Cn square. And then automatic weather stations and then regular field campaigns are required. And also to get the vertical characteristics, we carry out the tethered balloon or high altitude balloon flights. And finally, how to make use of a synergy of these measurements to finally reach to the main problem, what happens to laser propagation through the atmosphere. This will be the long standing problem, and the immediate research ongoing on this.
Can you come to the results part? Because
Sure.
you've already taken 11 minutes.
Yeah, sure. So these are the results. So this is an example of a balloon campaign that was carried out. So we have our sensors loaded on here, which is our payload. And this gives us a nature of how the vertical characteristics of CN square and aerosols are measured. This was carried out in the summer of 2024. And the first question to address was, how could aerosols affect refractive index fluctuations? So this metric delta CN square would be used. All those data that we have been using will be fed into a radiative transfer model to see what is the change in temperature that is imparted by atmospheric aerosols. So this leads us to some results like this. This is the vertical profile of how much temperature fluctuations can be introduced by aerosol absorption. So these are for different seasons. For the sake of explanation, I will be looking into this particular profile, the red one, which corresponds to summertime. You can see some unique peaks in this profile. And on the right side, what you are seeing is how much fluctuations in refractive index is brought about by atmospheric aerosols. This is part of a sensitivity study. And what can be observed here is, as you move from the residence, a parameter that is shown here is how much time these aerosols can reside in the atmosphere, which we call as residence time or lifetime. As the residence time of aerosols increases, the refractive index fluctuations are also seen to be increasing. And is it significant? It is significant enough to impart a change in refractive index fluctuations from a weak turbulence regime to moderate turbulence regime. So this means aerosols can impart changes in atmospheric refractive index fluctuations, and that is not something trivial. It can even lead to change in some turbulence regime. So this answered our first question, aerosols can introduce changes in optical turbulence. So we looked into some another aspect where highly absorbing aerosols, or what we call as soot particles, were considered. A balloon flight gave us profile of atmospheric black carbon, which is highly absorbing in nature, and which should more clearly show some signals for atmospheric aerosol effects. And the black curve is black carbon measurements, and the red curve shown here is the profile for refractive index structure parameter. And what you can see here is, at an altitude about 4.5 to 5 kilometer, there is a large layer of BC, black carbon, present. And more interestingly, at those same altitude itself, there is a large dip in this refractive index structure parameter. And it's about 4 or 5 orders of magnitude reduction. What happens here is, these BC aerosols absorb solar radiation, heat up the atmosphere, and this in a way reduces the temperature difference between the surface and that high altitude, which reduces the thermal mixing happening in the atmosphere. So it increases the stability around these layers. Due to this, it happens to be like this altitude where this elevated layers of BC is present, there is a large reduction in optical turbulence, which makes it conducive for laser propagation to be more efficient. So what could be the application for this? Suppose you want to implement such a communication link between maybe Bangalore and Mysore. It is not possible to do it in a single stretch because of the inherent curvature of the earth and buildings and trees and all those things. An interesting approach followed is shoot a beam from Bangalore to some high altitude platform, drone or balloon or UAV or something like that. Take it from here to another UAV or drone, shoot it back to Mysore. Two questions exist there. What should be the height at which these high altitude platforms should be floated? And how do you know what altitude is that? These results give some possible explanation or solution to that. Shoot a laser beam and do some laser remote sensing study. Understand the vertical characteristics or profile of black carbon aerosols. If this result holds true in all conditions, then the layer where black carbon is seen in large concentration could also be a layer where refractive index fluctuations are less. So if you want to implement such a communication system, float your drones or UAVs in those altitudes. This reduces the power of laser beam required to implement the system, which cuts down the cost a lot. So the main takeaway points from this talk is aerosols can introduce atmospheric optical turbulence, and that depends on a lot of characteristics of aerosols, such as single scattering, albedo concentration, and vertical distribution. And optical turbulence models for Indian conditions, we need to develop them because the models that are existing now are not faithfully capturing the measurements that are obtained from this region. And this is a result of such a model developed from our lab. So this is a reference CN square and this is our predicted CN square. It doesn't account for aerosol effects, but still we were able to capture the effects to a large extent thanks to some improved physics incorporated into the model. I'm not getting into detail into the models in this, but the takeaway message is we need to come up with models which would also account for aerosol effects as well. Because as of now, all the existing optical turbulence models considers a condition called clear air turbulence or CAT, where no pollutants, clouds, nothing is present. But in this case, we have seen that aerosols do impart changes in refractive index fluctuations. So it is quite essential for us to come up with models accounting for aerosol effects as well. And this could have a lot of applications. It could be spanning from satellite to earth communication or laser remote sensing, optical astronomy, or directed energy systems. And obviously, this calls for interdisciplinary research, making use of a lot of atmospheric observations of aerosols or atmospheric boundary layer. And then it also called for optics or communication groups to come up and do this research as well. So with this, I'll conclude my talk here. So I would like to thank the funders and my collaborators here, and the host institute, our founder director is also here, for giving a lot of support to carry out these measurements and campaigns. Thank you so much.
Any questions?
Thank you. Thank you for the interesting talk. I have a question because aerosol is a generic term. You have a lot of chemicals in that, and it can vary. Like sometimes hydrocarbon, sometimes freon. So, is there any specific chemical interaction? Is one part of my question. And listen, second part also. You have this laser communication based on the laser wavelength. Is there any particle size distribution which is crippling your communication effect?
Okay.
For example, 10 micron particles, 3-4 kilometers up. You mentioned about it. So these two questions you can address.
So for the first question, the effect of aerosol or whether what aerosol is can influence this depends on three parameters of aerosols. It's concentration, vertical distribution, and so on. And more than that, single scattering albedo, which tells how much scattering to total scattering plus absorption is contributed by these aerosols. So if it is something like a soup particle, it will absorb a lot. So they can bring some variations in atmospheric temperature. But compared to that, some aerosols like sulfate or sea salt, they won't contribute anything to atmospheric temperature change as such because they don't absorb anything. So we need to come up with some accurate models or measures for single scattering albedo to give a quantification for whether all aerosols or some aerosols would be imparting that change. And the second part about the wavelength aspect, the aerosol effects would be large if the wavelength and the particle size are matching. And in perspective of scattering. Because based on my theory, if size of the particle and the wavelength are similar, then interactions would be higher. If that's the case, something like 500 nanometer or 600 nanometer would be the ideal wavelength where all these aerosol effects based on scattering would be present. But there are also some wavelengths where absorption would be higher. So that would be higher for lower wavelengths, something like 300 nanometer or 400 nanometer. There, the absorption effects would be larger. But if you're going with that, then the total atmospheric attenuation may also come into picture.
The particle size can change, the dynamics.
Yes. There would be a continuum.
Yeah, due to rain, many other parameters.
Yes.
Do you take care of that?
No, as of now, it is not taking care of those dynamic changes.
Just a very outsider sort of question. When you're trying to transmit information using laser, you are presumably going to change the laser intensity. That's where the information is encoded. And now this laser is going through atmosphere and there'll be fluctuations in the laser light. So what is the standard deviation in the fluctuations because of turbulence? And you need a certain range of change in intensity of the laser to transmit information. Will it drown out all the information that you're trying to send, the turbulence or the aerosol?
So the results that I have shown here are not based on actual laser propagation studies. These are all based on the initial atmospheric characterization done. So I guess the question that you asked is, if intensity is too much, will it lead to some issues? So that may actually lead to something called as saturation regime. So where actually, based on literature, it is shown that there is not much increase in the influence of atmospheric turbulence on propagation. So there is something called a weak to strong turbulence regime. In between, the effects would be predominant. Beyond some range, it is not observed. So I think I have to also carry out some observational studies to validate this.
Are there some situations where where this can actually help the communication? Can it sort of augment certain frequencies and certain kinds of aerosols can do that?
So this was actually shown as advantage in communication system, or more importantly in aerial FSO communication, because classically this soup particles are considered as a problem in communication because they can lead to more absorption or scattering. But if such suppression in optical turbulence is happening, it can overcome the deleterious effects brought about by absorption. So this can actually act as a boon in aerial communication.
So another nice contemplation. So this elevated black carbon layer, so that height will change, right, with debris and also seasonal variations. So that also has to be taken care of.
Yes.
So do you have such data of variations
of
no. Changing this altitude?
No, this is observed. This is obtained from a previous balloon flight. Okay. We don't have data for dynamic changes with respect to that.
Okay. And also, there will be so much of interference with light pollution, I would say, in terms of differentiating between your signal and the noise in the background, because there are other lights which are scattering from these particles. And so do you think those are also considerations for geographical locations where these kind of communications may be made use of, or maybe in the cities it will be much more difficult compared to lower bottle sky level areas?
It will obviously be a problem if we have background noise in between. But as far as a communication engineer is concerned, that is not something which would be more troublesome as compared to this random fluctuations in refractive index. So those effects can be overcome by engineering design or something. But these are out of hand, and so it would be having an upper hand when you are doing this link budget analysis.
So I have one or two questions. So you mean if the atmosphere is more turbid, you have more turbulence in the atmosphere, especially when you have dirty particles like black soot. But how far in the atmosphere these carbon particles reach? I'm sure they may not be reaching beyond 4 kilometers or 5 kilometers. I see a major spike here. But most of the air traffic moves above that layer, say 10 kilometers or 11 kilometers. So I'm sure these are not going to affect the turbulence or the movement of the planes, the air traffic.
Okay.
So, yeah. So what are the other factors that drive the turbulence in the atmosphere? Because many times we see the plane is just shaking up and down. Like recently we saw Singapore Airlines lost height of almost 1 or 2 kilometers, and one person died. So what was the reason for that?
So there are two main sources for this turbulence.
This is probably at troposphere, stratosphere layer?
This is troposphere only.
Yeah.
So in this case it would go to some 15 kilometers.
So planes move, fly above.
Yes, yes. So there are two sources for turbulence. One would be thermal driven, which is based on the temperature fluctuations between the surface and the upper atmosphere. The other could be due to the mechanical aspects, which is wind shear. What is the vertical gradient in wind shear? So the high altitude turbulence experienced by aircraft is usually due to this wind shear fluctuations. And the other aspect that you asked rightly, that whether these particles can go to high altitudes, it can go, but not.
But very rarely, because these are quite heavy particles.
Not due to surface convection, but as you told, the aircraft emission is a serious source for such emissions in the higher altitudes. It can be there.
Back to one or slide where it is this one. So I could see post-monsoon, these aerosols here at lower altitudes are more. What is the reason? Normally, the aerosols are washed out post-monsoon.
So this is a classic case of atmospheric boundary layer dynamics. So in summer, we have larger surface temperatures where the thermals could rise to very high altitudes.
But this is the time when the summer is no more.
No more. So during the winter or post-monsoon, the surface temperatures are less. Even though the surface concentration would be less, whatever is there would be within some few kilometers or so. So even though the surface concentration is less, if you check the peaks here, it may be larger. But you won't have anything in the higher altitudes.
Thank you. If there is no other question, so let us clap for both the speakers, Dr. Burman and Dr. Sharma, for their wonderful talk. Thank you.
Thank you, Professor Gupta. Now we break for tea, and we reassemble at around 11:25. I think we are running slightly late. 11:25. Okay, 20 if you can. Okay. Thank you.
And to take you through this, I invite the chair, Professor Mondal, to chair this session.
So, thank you all. So welcome to this last session. And the first talk in this session will be given by Dr. Dhiraj Kumar from the International Center for Genetic Engineering and Biotechnology, New Delhi. And Dr. Kumar was elected fellow of our academy in this year, 2024. And the title of his talk is given there, Understanding and Solving an Ancient Disease Through Modern Approaches. Dr. Kumar.
Thank you, Professor Mandal. So, am I audible? This we have got this bad habit in virtual meetings to ask first that am I audible. I'm really thankful to the Academy for electing me and inviting me for the talk today. The title of my talk is Understanding and Solving an Ancient Disease Through Modern Approaches. So we have seen different flavors of scientific discussion in last 1.5 days. So I think this is one of the first where we will deal with infectious diseases, and the one that we focus on in our lab is tuberculosis. Yeah, is it better? Yeah. Okay, thanks. So ancient disease. So when we use ancient, we think of Egyptian pyramids and the Mohenjo-daro civilization. But tuberculosis is way older than that. The genus originated several 100 million years ago, and almost 3 million years ago, actually, the current tuberculosis strains kind of diverged, and the modern species of tuberculosis originated around 30,000 years ago. And while I showed just for the ancient reference for these Egyptian and Mohenjo-daro excavations and mummies in Egypt, they have been found to be having tuberculosis lesions when the X-ray and other analyses were done. So really, this is an ancient disease, and it has affected the mankind for a long, long time. And probably it's high time you start looking for solutions to this. So before the modern medicines became available, people were aware of what tuberculosis is and how it is impacting the life. There was no treatment at that time, of course, and the only solution was sanatoriums, usually at high altitude, cold places. The idea was that clean air, cold temperature is what delays the inevitable, but it hardly cured. Some of them were lucky enough to get cured, but nevertheless. And then in 1930s, when you had discovery of antibiotics, there was expectation that the era of bacterial infection will be gone because you have a really, the bullet to kill all the bacterial infections. But then it was a very short-lived euphoria because what I'm showing here is a chronology of some of the classic antibiotics discovery. And when the resistance against those antibiotics were reported, so here is the year of discovery, and here it is the year of resistance identified. And you can appreciate that for something like carbapenems, the discovery of resistance happened almost in the same year when the drug was released in the market. So what I'm trying to emphasize here is that all antibiotics by design are destined to face this problem of drug resistance. Because we all know the Darwin's natural selection, and the antibiotics actually select against this very strong pressure that the bacteria undergoes when they are exposed to antibiotics. So tuberculosis is no different. Like all bacterial infection, TB also develops drug resistance, and this is almost 12 years old story. Which came just around the World TB Day, which happens to be around 24th of March every year. Around 12 patients of totally drug-resistant TB was reported in Hinduja Hospital, Mumbai, And all of them died before their drug resistance profile was even measured at which drug they are susceptible to or vulnerable to. It's almost like road closed. Once you have totally drug resistant, there is no way you can be cured. And given the antibiotics, vulnerability to developing new resistance, you need to come up with newer ways to target tuberculosis so that you can circumvent the problem of drug resistance. And so the work in my lab has mostly been focusing on those alternate approaches. So not really looking into antibiotics, but something which you can use to avoid the generation of drug resistance, and also something which works effectively in both drug-resistant and sensitive bacteria. And for that, we are targeting host mechanisms. Why host mechanisms? While I always use this slide to, kind of convey across the message that why host physiology is very important in driving TB pathology and how you respond to TB infections. Almost all of us have witnessed in last 4 years what happened during COVID. So all of us responded very differently to coronavirus infection. And a very live example of that happened in a very unfortunate manner in Lübeck in Germany in 1930s, where in a neonatal ward, around 270 newborn kids were kind of inoculated with a virulent strain of mycobacteria instead of the vaccine strain. Vaccine was just discovered around that time, BCG vaccine. And all of those were inoculated with this virulent pathogen. Some of them died within 3 months of tuberculosis. Around 70 odd kids died. And remaining 200 kids, they developed severe, moderate, mild to no symptom at all. Now, I mean, that was a disaster at that time, but now if you look back, this becomes a powerhouse information that how host physiology would have distinctly responded to the challenge they were exposed to, and kind of saved different individuals, but not worked in many others who were unfortunate and died. What it highlights that if you are able to understand host-MTB interactions in a much more clearer manner, probably you will have an additional handle where instead of antibiotics, you can modulate host functions, and that will allow you to control TB infection much more efficiently. May not be alone, you can combine it with antibiotics, but certainly it gives a new hope that you can develop something called host-directed therapy against bacterial pathogen. So it's an alternate way, and you can think of the added advantage that since you are targeting host and not the bacteria, the chances of developing drug resistance is minimalized because there is no natural selection pressure as such coming on the bacteria. Of course, it can come up with newer ways. How to identify which host factors, which host pathways are the main culprits behind allowing bacteria to establish, cause infection, cause disease, and things like that. They are certainly hidden inside us. And one of the earliest attempts that we did a long time back, this was my postdoc work early in 2010 and before that, where we did a genome-wide screen to identify are there host factors which specifically regulate intracellular bacterial survival, mycobacterial survival per se. And we identified several pathways and molecules which could be involved in regulating bacterial survival inside the macrophages. And once you identify that, you realize that almost all physiological processes together looks like they conspire together and allow bacteria to cause infection. It may be that bacteria is hijacking them in a way that it helps the bacteria more than helping the host. But just to give the highlight of the way interaction happens, so you generally inhale the bacteria which enters the lungs, and that's the most standard TB, but now we know that TB happens all over the body in different parts. And there in lungs, it goes to macrophages, which are the central and immune cells. And almost all the physiological processes that people study in innate immunity and in cell biology, almost all of them are perturbed upon infection. But over the time, for the long-term cellular responses, what happens that the gene expression pattern also gets perturbed, and that decides whether the bacteria is going to survive and grow, or it's going to persist, or get killed, and accordingly, you will have active disease, you will eradicate TB, or you can have a latent infection which can then resurface at some other time when you are down in your immunity. So the 2 points, one is that host physiology plays an important role in tuberculosis pathogenesis. And if you understand it well, you can find ways to modulate, regulate it, and come up with host-directed interventions against tuberculosis. So my lab mostly focuses on all the host angle at different scales. So we look at tissue levels, where we look at different cell types which are recruited to the lesions where tuberculosis happens. This is called granuloma. It's this is human lung granuloma image generated from our group only in collaboration with AIIMS, where we were looking at different immune cells which are coming to lung tuberculosis. And we looked for characterize different cell types, and we showed that how they can actually help bacteria to propagate better and cause infection. We look at intracellular trafficking events, that how bacteria goes from one compartment to another in a given cell. So we have looked at autophagosomes and how that interaction regulates inflammation, which is kind of hallmark during TB infection. We also look at different subcellular compartment trafficking, vesicle movement, bacterial uptake by the macrophages. What are the mechanisms that regulates the bacterial uptake? And at molecular level, we have been extensively analyzing gene regulation, splicing event, and whole genome variations, which can tell us whether you are susceptible, vulnerable, or tolerant to bacterial infection or not. So while I will not touch upon these probably some other time, so what I'm going to talk about in a little more detail in next few slides is the regulation of alternative splicing, which really has come up as an exciting discovery from our group, something which has never been reported in any bacterial infection, and that gave us some very interesting insights. So to begin with, we had done a simple microarray experiment. If those of you who have probably just heard about microarray, it just gives you the overall pattern of gene expression in a cell upon any kind of perturbation. You can give it heat, bacterial infection, or anything. And based on these heat color map, you can show the red ones are upregulated, green ones are downregulated. So it gives you the whole snapshot of the whole genome, what happens there. But that's microarray, which is like hybridization based. It doesn't give you a very clean picture. Why clean picture is required? Because eukaryotic genes are actually discontinuous in nature. When I say discontinuous, the coding regions are interrupted by non-coding regions, which are shown here as lines. And then they are stitched together in the process of transcription through a process called RNA splicing. So these are stitched together to form these functional messenger RNA, which forms the protein. Now, these functional messenger RNA, you can appreciate here that these blue and gray boxes I have used exclusively in one case versus another. So what I'm trying to convey here is that these coding regions, or you can call them as exons, these are spliced differently to give different kinds of sequences. And you can appreciate that because of this, the protein sequence and structure also will be different because the coding regions are different. So from the same gene, you can have different, you can call it as splice variants or isoforms. That information you cannot get from normal microarray experiment. And any gene you pick up and put it on Ensemble, which is the standard database, you will find multiple splice variants of a given gene in the database. What we had done several years ago, we did RNA-seq analysis. It's a very high depth RNA sequencing analysis from the MTB-infected macrophages. And the observation was that infection and strain-specific perturbation of splicing happens in MTB-infected cells. And if you look at what are the functions which are getting affected through splicing, what you realize that these pathways, apoptosis, gene regulation, innate immune responses, these are the standard usual suspect pathways which will actually work against bacterial infection. All of them were getting targeted through alternative splicing. Then through functional studies, what we showed that if certain genes are expressed in a full-length variant, it will form a functional protein and lead to bacterial killing. But what happens during bacterial infection is that it gets expressed as a truncated variant because of alternative splicing, which I talked about. And then it is not forming a functional protein, and this helps bacteria to survive. Basically, without getting more dramatic, if this is how your host response looks like, this is what bacteria does. It breaks into pieces, and then the host response actually gets blunted. Now, this was a story published several years ago, and at that time there were questions coming from reviewers, what is the mechanism? Because splicing is a very complex process, involves assembly of large multimolecular complex, the number of steps involved. And all these circles shown, it actually is a RNA protein complexes, which recognizes which splice junctions to use, cut, and stitch together. So it's a very complex process. So how bacteria knows that how to regulate, which proteins, target mRNAs to regulate. And we decided to follow with a hypothesis that mycobacterial proteins can enter the cell and nucleus where splicing event generally happens. And when that happens, it can interfere with the recognition of these splice junctions, and that can lead to alternative splicing. It's a working hypothesis, and we went into that using different high throughput and candidate approaches, and this was supported thankfully by India Alliance, otherwise this work could not have been done. And we actually did the host pathogen interactome analysis. And without getting into detail, you can look at whether two proteins are interacting or not. There are very different kinds of methods. We use a special method called yeast-2 hybrid, where we had all the bacterial secretory proteins and human splicing-related proteins and just check whether they are interacting or not. And we generated an interaction map and looked like that a lot of splicing-related proteins were actually interacting with the bacterial secretory proteins. When that happens, then we did some in vitro assays to see that whether bacterial proteins can alter host RNA splicing or not. And you can kind of relate to these. These are the exons, and then the lines are the introns. So you can clone this whole thing and express these as a substrate, and then whether all 3 exons are retained or only 2 are retained, this is spliced out. You can do it by normal PCR reactions. And we did the in vitro splicing reactions, and you can see in this case, 4 different MTB proteins were incubated during the reaction. And you see that the middle exon is retained in all the cases. But in case of another mRNA, the moment you bring the RV protein, this is the normal in the nuclear extract alone, but the moment you bring RV protein, the middle exon is spliced out. So what it means that in the presence of MTB protein, the recognition of middle exon is getting perturbed, and it is getting spliced out rather than getting retained. And this is something which is happening inside the cell, because in RNA-seq data, you are getting this differential regulation happening. So certainly MTB proteins can directly alter host RNA splicing. Now, coming back to this, I was referring to these circles, that they are small RNA nuclear complexes. This is how it looks like. It's a very complex RNA, which shows these hairpin loop-like structures and interacts with several proteins. And these are called snRNP, which has SMN complex and SM core rings. And what we found in the yeast-2 hybrid, that SMN complex proteins and SM core rings, both of those were interacting heavily with the MTB proteins. So we went back and did some more analysis, and what we realized that snRNP biogenesis is a evolutionary conserved process. It requires snRNA to be synthesized in the nucleus. It comes to the cytosol, it interacts with SMN complex, and then this heptameric core ring assembles over it. This is now snRNP. It goes back to the nucleus, where it participates in the splicing reaction. Now, what our data suggests that when this whole process is happening in cytosol of the cell, mycobacterial protein access them and they interact with these. And they interact and kind of sequester these in the cytosol. So once that happens, these proteins are not available to form these functional snRNP, and you will have a depletion of snRNPs in the cell, and that impacts overall splicing efficiency. So you have interaction of MTB proteins with these important complexes, and you have cytosolic access. You don't need bacterial protein to go into the nucleus. Even in the cytosol, they are able to access the splicing machinery because the whole complex comes to the cytosol. It's not restricted only to the nucleus. And that's the interesting part which we discovered while doing this work, that it's interesting. And just to show the example, this is how the bacteria, so these are the bacteria which are labeled with certain fluorescence marker, and you can see this is one of the SM core protein called SNRPF, which nicely decorates the bacteria. And this is never shown in case of any bacteria, forget about MTB, that it can interact with the splicing machinery such beautifully. And whenever, the splicing is studied in different contexts, in cancer, in spinal muscular neurotrophy. So in a lot of contexts, splicing has been studied. In fact, the SMN complex I was referring to, the name is actually referred from spinal muscular neurotrophy, SMN. So what is known in those fields, that any alteration in the, complex components leads to, massive alteration in the pattern of splicing. And everything that we referred earlier, we were seeing interaction with SMN protein, interacting with the SM core protein. Ideally, they should all lead to altered RNA splicing, and what we see during MTB infection is widespread splicing defect, several intron determination cases, and you get a lot of transcripts that do not get translated. So basically, that's the mechanism which in other contexts people have worked out. Looks like the exactly same thing is happening during Mycobacterium tuberculosis infection. And bacteria is smart enough to know that if you alter this snRNP biogenesis process, you have a control over the cellular response machinery. So while you express the gene, but it will not get into the functional form. And that's the beauty of the whole thing, that it happens. And then we did some more assays. We made some knockout of the mycobacterial protein we had identified and showed that it is involved in pathogenesis. And we also showed in mice as well as in human TB granuloma. So when you see human TB granuloma, there is strong staining for SNRPF, which is the protein we were looking at, suggesting that RNA splicing alteration is a very strong, correlate of TB pathogenesis. And if you have ways to alter that, probably you will have newer ways of targeting tuberculosis. Now, splicing people are trying to target in cancer, but there is no report in TB, and that is something which we will try to develop in future. I'll just finish in 2 slides. To some extent, we have done some analysis with the interactions, surface between the host and bacterial protein in collaboration with the structural biologists who are easily available in ICGEB. And we are trying to develop that to disrupt those interactions and see whether that helps. Some early results looks good. Last slide. This process of nucleocytoplasmic settling is a evolutionary conserved process from yeast to higher eukaryotes, right? And this is a quality control pathway, because if snRNP biogenesis happens only inside nucleus, some immature snRNP can start participating in the splicing reaction. And that is very deleterious, because they will start recognizing even the non-genuine sites for RNA splicing to happen. So this is a quality control measure. What bacteria does, it hijacks this quality control pathway. And we looked at the bacterial protein that we identify that interacts with the spliceosome. In all virulent mycobacteria, its function is unknown. In all non-virulent mycobacteria, it is actually a beta-glycosidase, secreted beta-glycosidase, suggesting that for a non-pathogenic soil mycobacteria, it's actually just used as a different carbon source. It can grow on different carbon source. But probably when it acquired the virulence and pathogenicity, it acquired the ability to alter host RNA splicing. Now, it's too big a statement to make. I'll have to put the non-pathogenic bacterial gene into the pathogenic bacteria and show what happens there. But still, the way it looks like, it tells us probably the evolution of pathogenicity in the context of Mycobacterium tuberculosis. So I'll stop here. Summary is exactly what we have already discussed. I'll acknowledge the people in my lab, especially Komal, somewhere here, who was actually, mostly it was her PhD work, and she has left. Funding from India Alliance, very well acknowledged. This could not have been done without their support, and of course collaborators and everyone else. Thank you so much, and we're happy to answer any question.
Thank you, Dr. Kumar, for a nice talk. Now, can I take a few questions?
What actually triggered this tuberculosis strain to appear sometime 150 million years ago? That was the time. It was in geological report, it was Jurassic, when warm and humid conditions prevailed across the earth, and the Indian subcontinent witnessed lots of transgressions.
Probably.
So what was its predecessor?
Those events happened probably when it was still, the evolution was happening in Africa, and, because it's almost 100 million years.
Evolution of what in Africa?
The pre-hominids.
So, no, you talk 150 million years ago. That was
no.
Hominin.
No, that time nothing was there. But I'm saying that the pre-hominids, and they were getting infected with mycobacteria. Those events didn't happen that bang, but it started probably in Africa. And
150 million years to 1.7 or 1.5 million years is a huge time.
Yeah.
So
it's a huge time span. Yeah.
The other thing, I have a question. You said 5,000 years ago the strains are found in Egypt, and 3,300 years ago in the Indian subcontinent.
Yeah, those are, I wouldn't say with very strong conviction that years are exactly the same. It can be 2,000 to 2,000 years.
As a layman, I like to know whether the tuberculosis spreads during warm and humid conditions or dry and cold conditions?
Warm and humid. So
Warm
you
and
this,
humid. So
yeah.
that was the time when the conditions in the Indian subcontinent were cold and dry, 3,300 years ago, and 5,000 years ago also in Egypt.
Yeah, I have no answer for that. The only interesting part is, from these mummies, these guys were able to isolate bacterial genome, and they sequence it. And when you analyze that, it's almost 99% kind of retained even in the modern current day bacterial isolates. So much is the level of conservation in mycobacteria. So that's very unique aspect about it. I don't think for any bacteria you will have such long history of genome sequence available. So they actually went and did it from the Egyptian mummies isolated, and that was a Nature paper almost 10, 12 years back. Yeah.
During British time, people used to go to Rani Khet where lots of pine trees.
So one of the images I showed, that is still there in Nainital. So that sanatorium is still there in Nainital. It's different matter and nobody goes there because you have antibiotics and all.
So
one question, right at the back. Nice talk.
Thanks.
Is there any evidence to suggest that XDR strains would behave differently when they're splicing compared to susceptible strains? That's the first question. The second question is, when you said that this has not been described in other bacteria, is it because people haven't looked for whether this is happening in other bacteria that live in macrophages?
So for the second question, most likely people haven't looked at. There is one RNA-seq study done in Salmonella where you do see signature of it happening, but nobody has followed it seriously. Regarding the MDR strain, it can happen that some certain drug-resistant strain alter RNA splicing differently for simple reason that people have characterized secretome from normal wild type and MDR TB samples, and it is found that the secretome varies dramatically, right? So some of the proteins get heavily secreted in the MDR variant and not in the normal wild type sensitive strain, and vice versa. So if that happens and they have the, they are from the list that we have identified interacting, probably you will expect that some differences are there. But we haven't followed with the MDR TB cases as such.
Thank you.
Yeah. Thanks.
Okay. Yes.
So what is that SMN complex?
So SMN complex is there are a lot of these proteins and SMN proteins. The name comes from spinal muscular neurotrophy. In Drosophila, people identified genes which were involved in, you can see, that mutation leads to SMN phenotype. So they named it as SMN, but, it recognizes the 5' end of the snRNA and binds to it. And once that binds, it's a step called assemblyosome formation that allows assembly of other proteins on the snRNA. So it's part of the snRNP biogenesis process, very well characterized in literature.
What is the main function of it?
No, so main function is allowing the assembly of snRNP to happen, right? So without that binding, your other heptamidic ring I was showing will not come to this. It allows that recruitment process to happen, right? Okay.
Any further question? One short question.
Okay. Very strange splicing mechanism. Wherever it is known, are those bacteria also equally ancient or they vary?
No. So splicing is happening in the host. So it's not happening in. So bacteria is only driving it in slightly different way than what happens usually, right? And that study that when a bacteria enters a splicing may get affected is not done in other bacterial cases. So that's what I was trying to. Yeah.
Thank you. Thank you, Dr.
Okay.
Kumar.
Thanks.
Again. And then we call the next speaker, Mayuri Rao. And Mayuri is from RRI, Bangalore. So, and she became Associate Fellow last year. And she will be giving a talk titled Experimental Cosmology at Radio Frequencies.
interesting features that arise from helium and hydrogen interaction and feedback processes. But to give you a context, this signal has never been detected. Okay, that is because. Before I get to that, so why is this interesting to us, right? This distortion, what we call the CMB spectrum from recombination, is one of the very few cosmological processes that can be studied today with a very clear time axis. Okay, so it will help us study the thermal and ionization history of the universe with excellent precision, because each of these lines that we are seeing in the distortion has a very clear time stamp. Okay. Secondly, it's a direct measure of pre-stellar helium abundance, and metallicity and abundance is a very actively studied topic in astrophysics, but all our understanding of helium abundance comes from theory, and we are seeing things in the early present universe, but somewhere you could be able to measure the actual amount of helium that got formed in the early universe if you're able to make a precision measurement of the spectrum. It's an additional probe of cosmological parameters. I have two such here, total matter density as well as actual amplitude of the CMB temperature. And each of this has a slight perturbation or results in a slight difference in this recombination spectrum. It's also a very interesting way to study any evidence of other mechanisms of energy injections. Theorists have written papers on using this as a probe to study dark matter annihilation in the early universe. I'm not an expert, but I'm hoping to motivate you with this slide that it's a very useful and important experiment in cosmology and in physics. And the reason why the signal has not been detected to date is because this is the dynamic range that we're talking about at the very least. The blue solid line is the CMB blackbody spectrum, peaking at around 2.8 Kelvin. And way down here, about 9 orders of magnitude below, is this recombination ripple or cosmological recombination lines from the very first hydrogen and helium atoms. The best measurement of the CMB spectrum to date is at a part of 1 part per 10,000 or 1 part per 100,000. So we need to get 5 orders of magnitude better than the current best measurement, which I might remind you is over 25 years ago. So technology has improved since then. There are, of course, practical challenges. So the first question we ask is there a fundamental challenge? Is it feasible, even in theory, on paper, to make a detection? And that's what we did way back when. But I won't spend too much time on this. I want to get to newer work, but we can come back to this. So the idea is that we put in simulation various fundamental limitations to a detection of the signal. So we put in a model of the foregrounds that lie between us and the signal, primarily dominated by our own galactic synchrotron emission. The CMB itself, like I said, is 9 orders of magnitude brighter, so we included that. We put in some basic receiver thermal noise, and for different amounts of receiver thermal noise, we can see that there is a nice frequency range for a ground-based experiment. Atmospheric cutoff is at higher frequencies, where the signal-to-noise ratio peaks, right? So this motivates the use of cryogenically cooled receivers to achieve the required signal-to-noise ratio in realistic time. So the simulation suggested that for detection, one would need an array of about 100 mini-cooled radio telescopes observing the sky for 1 year for a 95% confidence detection. It sounds like a large, daunting number, but I'm going to tell you soon that it may be possible. Again, the other thing to point out is the frequency range where it peaks is around a few gigahertz. Okay? So we decided to start looking into this frequency range a bit more. An important caveat for all these results is that we assumed an ideal telescope. An ideal telescope has properties like over the entire frequency range, your beam of your antenna, which is the sensing element of a telescope, is perfectly stable across all frequencies. And that brings me to the newer work. So again, one important concept that we kind of brought into the picture was a definition of what we call smoothness. And the reason why this is important, and it sounds like I'm changing tracks here, is because we need to find a way of separating all these foregrounds that I mentioned earlier from the signal to be able to say I have detected the signal. And an important arsenal in our toolkit is that the signal we are trying to detect is very, very well predicted. It has a very distinct shape we're trying to find. There's a strong pattern. I'll show you that in zoom in soon. But all the foregrounds, astrophysical foregrounds, galactic emission, the CMB, etc., they don't have that shape. So we want to exploit this property as a basis of separation of the signal from the foreground. And that mathematical basis is this function, what we have defined. We call them maximally smooth functions. For the mathematicians in the room, many of you, this is a slightly modified version of a complete monotone function, but we have placed some caveats on how this signal, mathematical shape can change in derivative at lower and higher orders. So without getting into the jargon, this is what the signal looks like in the frequency range of our interest, 2 to 6 gigahertz. So it's a really nice ripple-like feature which cannot be mimicked by astrophysical phenomena, right? But it can be mimicked by our own instrument. So our feasibility study assumed as a basis that we cannot do these things with our instrument. But in practice, an instrument can do this all the time. It can do this by way of standing waves in a cable. It can also do this because when you look at a foreground, which basically is our galaxy, and the antenna beam you're pointing changes in direction at each frequency, it can leak spatial structure on the sky into spectral structure in your data. So basically an antenna can do this. So we have gone on now, yes. So this is intern Darshan who worked with me a couple of summers ago and we're writing this up. So what Darshan did was he took a toy model of an antenna, a sine square theta beam, and let the beam vary with frequency. So what you see below, and I'm sorry, I don't think it's in time sync, the beam is getting fatter with frequency in one case. The beam is shifting in frequency in the other case. And using this as the beam instead, not an ideal beam that was used in the feasibility study, we still find that we are able to recover metrics of signal detection even with a non-ideal antenna. And we're using very simple things like Pearson correlation coefficient or some Euclidean distance to distinguish between the case where a signal is injected in our model as well as in a null hypothesis case. Signal is absent. And we're able to tell the difference, okay? So that leads us to building the actual thing. So we have some parameters that we think are more sacred in the antenna design versus other. So keeping those in mind, we have already built this antenna which has been tested in the field and validated to be ideal to 1 part in 10,000, okay? And we're also putting together the first cryogenically cooled receiver chain that will go with this antenna, and we'll be out in the field, I guess, by the end of the year. And just with this one element of a nice antenna with a cooled receiver, we can do some very interesting science. First of all, if you look at the frequency versus CMB measurement plot to date, all the beautiful numbers I told you, 1 part per 100,000, is at very, very high frequencies. Okay, about at least 10, if not 20, 30 gigahertz. At the lower frequencies where this experiment will operate, the error bars on the CMB are really large. And people have gone to the field and there have been various reports of detection of some excess radio background, and this has been attributed to, again, some exotic dark matter. So this is open play area for physics and astrophysics, and which is very nice. So we hope to go and tighten the error bars here and see what interesting science lies here, which has not been measured to this accuracy to date. And that can be done with this antenna and this receiver. So the other important thing for this experiment is to go and find a nice site for the experiment. So we were out in various locations in Ladakh last summer to make some of these measurements. And we did a quick RFI survey. This is probably the cleanest you will see anywhere in the world, okay? On the y-axis is just time. X-axis frequency from 500 megahertz to 6.5 gigahertz. And the dynamic range here, we're at minus 90 dBm, which is very, 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 very clean, okay? You don't see any lines at all, and whatever little bit you may see are satellites that you will never get rid of from anywhere in the world you go to. So we have an excellent site to put this telescope. For contrast, Bangalore looks something like this. The numbers got cut off. I can assure you it's several orders of magnitude worse, which means that we have to stay clear from places like Bangalore or city which have heavy levels of radio frequency interference. The other important reason to go to Ladakh is the contribution from our own atmosphere. as you try to go to higher frequencies and try to make experiments that you want to be sensitive to 1 part per 100,000 and better, your own atmosphere, Earth's atmosphere, can contribute to noise as well as can start attenuating the signal in ways you don't understand. So Tanmay Singh, who was a student with me back then and is a grad student at ASU now, led this work. And what I want you to take away from this plot is that here is Hanle in this little blue circle here. We also found a few other sites. Is that the actual thing that is represented in the bubbles here is the number of months out of 168 months where these regions have a precipitable water vapor of 1 millimeter or below. And this is a metric that is very commonly understood in the field of submillimeter astronomy. And this is a bonus thing for us because there is currently a lot of interest in India for astronomers to build a submillimeter telescope in the Ladakh region. So we have done this with what is called reanalysis data that the meteorologists in the room will be familiar with. And we have found that not only is Hanle an okay site, that there may be better sites also out there that are worth exploring for the science, right? And from this, we have been able to make some nice plots like this, which tells you the transmittance of the atmosphere over a wide frequency range. Well, kind of 0 gigahertz, but let's say very, very low frequency, all the way up to a terahertz. And this data, like I said, can be used to not only find an ideal site for this Apsara experiment, but also for a future Indian submillimeter telescope. And this is something that we are writing up and will be submitted shortly. So I may be the first speaker to finish before time, so I may take more questions, but I'll just leave the slides summary up here. I introduce you to what the cosmological problem is and hopefully motivated that it's an interesting problem. Also discussed the feasibility of detection with a very ideal telescope, and also shown you that even with some non-idealities, we are beginning to see that it may be possible. And with the very first element of this array that we are putting together, we can do interesting science with that. We've conducted RFI surveys, and we've also started studying the atmosphere contribution to the noise of this experiment, but also as a site survey for a submillimeter telescope. I'll take questions. Thank you.
Okay.
Yeah.
So we have lots of time for questions.
One observation
Yeah.
to suggest you, can you show India's different cartoon map?
Yes.
Actually depicting any part of India
Yeah.
correctly is a punishable.
I understand. Yes, yes.
So please do not show this with this blue line as a continuous line. You can just remove that.
We'll do that, yeah. So the red line, of course, we have taken from the India GIS.
This is a public platform.
Yes.
This academy is funded by the Ministry of Science and Technology.
Absolutely, yes.
Officially, the Parliament has passed a Geospatial Act in 2016
Mm-hmm.
to show any part of our nation.
Yes.
Differently than it is.
Oh, I understand, yeah. So red line is the line we are acknowledging. I want to put that on record, yeah. Yes.
Okay.
Yeah, nice talk.
Yeah.
I am from Mid Community basically.
Yeah, okay.
Yeah. So this ERA 5 data. that
Yes,
you used,
yes.
So how good is the data in this mountainous region? Have you done any
Yeah.
verification with the in situ observation?
Yes. So
my
we.
suggestion
Mhm.
is that
Yeah.
there are some reanalysis even generated in India.
Mhm.
Okay, I
Yeah.
can offline tell you that.
Sure.
So IMDA reanalysis, we have some GFS reanalysis where more of Indian data has gone.
Right.
ERA 5 uses less
Yeah.
Indian data due to various
Yeah.
reasons. Can also try to look into that.
Absolutely.
There are some very good satellite data also coming.
Yeah.
Where I think this water maybe, but I have some reservation now. ERA 5.
I understand, yeah.
How good it is over Ladakh.
Yeah. Yes.
Because reanalysis basically, I mean, it is very common.
Yes.
Reanalysis means the observation that I am not getting today, I am getting tomorrow.
Yes.
I am reanalyzing the data and preparing a more accurate representation of the atmospheric state, right? But for Ladakh, there is neither any data today, nor there is any data tomorrow, nor there is any data day after tomorrow. So it will remain same as it is.
Yeah.
Okay. not affect your accuracy.
No, I understand, I agree. So what we have done is, we're doing two things to address this, and I'll be happy to take the Indian analysis from you. We also wanted to compare this with other global sites, so we used ERA5 because it's global. We used ERA5 analysis against one set of measurements we found at Hanley at the Indian Astronomical Observatory, and on that basis we choose ERA5 over MERA2. So that is the best we could do. We are in the process of putting together some mini portable PWE measurement systems using GNSS, and hopefully we're going out this summer to deploy the first of them as a trial, and we plan to deploy this all over because we want on-ground measurements at some of these locations that I showed, but it will be great to get higher quality data for Ladakh for this. Thank you. Yeah.
Any more question?
Yeah.
Mm-hmm. In the gas phase chemical reaction, helium plus H2 plus or helium plus H2.
Mm-hmm.
So molecular beam experiments, and that give very accurate cross section as a function of collisional energy.
Yeah.
And those are actually verifiable with very accurate theory also. So it gives cross-section or rate constant as a function of collisional energy within the range of 0.1 electron volt, where your 0.004 electron volt is 1 terahertz. So those data are published in various internationally reputed journals. So these can be taken and convert it to your finding, and can be compared because these are atmospheric reaction, higher atmospheric reaction. Those are actually mimicked in the laboratory. Okay, particularly in the West, the experiment in India, people do very accurate scattering theory.
Yeah.
So this is comparable. Actually, one can compare.
Okay.
It's comment.
Okay, thank you. Yeah. So I believe at least this simulation I have on here, this was of course back in 2017 or 2018. And at that time, this was the latest prediction that included also several levels and suborbitals of heliums. In this community, that was the first time this was done. I'll go back to the theorists and see if they are including the more recent measurements and so on for helium. Yeah.
Any more question? I see no hand. So let's thank again Mary for this talk, and we follow the next speaker. Dr. Manoj Maji from National Institute of Plant Genome Research. Dr. Maji became Fellow of our Academy in 2022, and the title of his talk, Skip Jazz by Skip 31, a key event for seed maturation and desiccation tolerance.
This one. Thank you, Dr. Mondal, for introducing me to these audiences, and I also thank the Academy for giving me this opportunity. So I am going to talk about one of our research work on SKIP31 protein. So our lab primarily works on seed. We have been trying to understand some of the spectacular features of seed. We all know the overwhelming importance of seed in terms of agriculture, but seeds are biologically very interesting. It offers a lot of biological questions to understand. One of the remarkable features I have shown here, so seed can stay alive for prolonged period of time. So the seed has the ability to retain germination ability or viability for very prolonged period of time. Prolonged means really prolonged. It's not about decade, it's about a millennium. So here I am showing you two unbelievable example of seed longevity. One is date palm, which is khejur, which can be viable as many as 2000 years, and still even after 2000 years, seed can able to germinate and produce a successful plant. There is another example called lotus seed, ancient sacred lotus, in Bengal it's called Paddo. So they can survive as many as 1300 years, and even after that they can still able to germinate and produce a successful plant. So what is the secret behind the seed longevity? So this type of seeds which can survive in a desiccated state called orthodox seeds. So because they are desiccation tolerant, they can retain their viability for very prolonged period of time. Fortunately, most of the crop plants produce this orthodox seed like rice, wheat, chickpea. They produce orthodox seed. That's why we can store them and we can use them as per our need. So that's a huge advantage to the agriculture. There is another classes of seeds called recalcitrant seeds. So they don't survive in a desiccated state for a very long period. Even in some cases, they survive only for a week or only for a day. So these are some examples like oak, mango, lychee. There are lots of fruits. They produce a recalcitrant seed. That's why they don't survive for a long period. So our lab is trying to understand how does orthodox seeds stay alive for very prolonged period of time, while that recalcitrant seeds cannot survive for a very long period. What is the mechanism underlying seed survival, vigor, and longevity? How can seed survive for so long period? What is the mechanism to retain their viability or germination ability for a very prolonged period of time? And can we do something? Can we changes or manipulate these processes or genes to increase the seed vigor and seed longevity or seed storage life, which is a huge advantage for the agriculture? So what is the survival strategy of seeds? That's what we wanted to answer this. So seeds adopts a very smart strategy. It's called drying without dying. So they become dry, but they don't die. And that's why they retain their viability. So how they achieve this? So during seed development from zygote to the seed, actual mature seed, that's called seed development. So this during seed development, seed reduces the water content very methodically and organically. So particularly during the seed maturation stage at the end of the seed development, here actually, so in this phase actually, so seed drastically reduces their water content. When the seed reduces their water content so that they become dry, and there is a lot of advantage of becoming dry because they reduce the metabolic activity, so they can save their energy because there is a very less amount of metabolic activity, so there is a very less amount of ROS accumulation or toxic metabolites, and which is also, this drying also makes them resistant to pathogens. So this is one of the hallmark to stay viable for a very long period. However, when there is a drying, so it's very difficult to survive without water. So it's very difficult to stay alive in a drying conditions. So because it causes a lot of cellular damage, functional proteins damage, structural damage of the protein, like DNA damage, protein damage. So there are a lot of undesired modification happens in the seed protein, like isoaspartate modification, methionine sulfoxide modification. So plant adopts a very remarkable features that is called desiccation tolerance. So seeds acquire a desiccation tolerance during the seed maturation stage. In this stage, actually, so they have acquired the desiccation tolerance property, which actually allows seeds to survive for a very long period because they have to survive in a desiccated state. So this mechanism includes protection mechanisms and repair mechanisms. So our lab is trying to understand the repair mechanisms and protection mechanisms of the seed. So this protection mechanism includes a lot of sugars, RFOs, LIA proteins, chaperone protein, HSPs. They actually protect all the protein which undergoes damage in a desiccated state in the seed. And there is a strong repair mechanism in the seed, which includes the protein repairing enzyme like PIMT, MSR. They are called protein repairing enzymes. They actually repair this undesired modification and make them functional in the next. So this is achieved during the seed maturation stage, which is actually coordinated by the ABA hormone. So ABA hormone is a very common hormone in the plant. They actually play a very important role in various seed dormancy or seed maturation, seed viability. So this ABITF actually plays a very important role to induce this protection mechanism and repair mechanisms in the seed. So our lab is extensively work on protein damage and repair seed. We have identified a very anti-aging enzyme called protein A lysoaspartyl methyltransferase, which is highly abundant in the dry seed. So what it does, we have shown that this is a key enzyme for preserving seed vigor and longevity. So what it does during seed aging or during seed storage, the aspartate residues and the asparagine residues of any protein can spontaneously modify to isoaspartate. So this is spontaneous modification. It is induces during the dehydration stage of the seed or ROS accumulation of the seed. So when the isoaspartate is formed, it disrupts the protein original structures, which actually inhibits the biological function because of the isoaspartate modification of the protein. While the seeds have a lot of PIMT enzymes, so this PIMT enzyme can recognize these isoaspartate residues and convert them back to the aspartate residues. So the damaged protein become normal protein again. which actually restored its original function which has been disrupted due to the isoaspartate accumulation. So this PMT actually reestablishes the protein function which is actually required for the improved seed vigor and viability. So we have extensively worked on this protein and we have found these are the seed protein like catalase, ascorbic peroxidase, helicase, Lia protein, HSPs, lot of transcription factors. They undergo this modification and they lose their functions. While PMT can recognize this isoaspartate and make them functional again. But today I'm going to talk about another protein called SCIP31, how this SCIP31 modulates ABA signaling pathway in the seed and how it improves the seed vigor and viability. So during our textbook, we all know that ABA signaling is activated or ABA hormone is increased during seed dormancy. But while germination, this ABA activation or ABA signaling should be repressed. So how seed actually attains this ABA signaling during phase transition from seed maturation to seed germination, while because in this stage ABA signaling should be activated, while in this stage the ABA signaling should be repressed. So how seed actually does this fine-tuning job? So today I will talk about the SCIP31 protein, how they regulate ABA signaling pathway. So Vishal actually did this work. So first I introduce what is the SCIP31 protein. So SCIP31 is basically SKP1 interacting partner 31 is a nuclear localized F-box protein. So SCIP31 is basically an F-box protein, and F-box protein is a component of E3-SCF ligase complex, which is a part of the ubiquitin 26 proteasome pathway. So this proteasome pathway plays a very important role. It's a protein degradation pathway. It selectively degrades protein in cells. So what it does, this F-box protein actually identifies this target protein, and this target protein is to be degraded through the 26 proteasome pathway. So first we wanted to know whether this F-box protein is a real F-box protein, as it is a part of E3-SCF ligase complex. We found that SCIP31 interacts with the most of the ASK protein. ASK protein is basically a Arabidopsis escape protein, that's why it's called ASK protein. So SCIP31 interacts with the ASK protein and it's a nuclear localized F-box protein. So next, just to understand the function of any gene or any protein, you must analyze the function, where it expresses and when it expresses. So we found out that this SCIP31 protein is highly expressed in the seed. Here you can see as compared to the other organs, and through promoter gas fusion analysis, we can see that this is highly expressed in the embryo of the seed. To understand better, we actually check the expression pattern during the seed maturation or seed development stage. Here you can see in the late phase of seed development or seed maturation stage, the SCIP31 protein is highly expressed or upregulated in the late maturation stage, while this expression goes down once you imbibe the seed or once the seed proceeds for germination. That means SCIP31 may play a role during the seed maturation stage, but not during the seed germination stage. And it's also induced by the ABA, because as I told you that ABA hormone plays a very important role for seed maturation, seed dormancy. So it's also induced by the ABA hormone, and it's also induced by the dehydration. So that makes sense, because in a dry mature seed, it has a lot of ABA, and it's a dehydration stress conditions. So here you can conclude that SCIP31 is expressed predominantly in the seeds and during seed maturation stage. So now to understand the function of this protein or this gene, we need to analyze the mutant. So what is the phenotype of the mutants? So when we procure the mutants from ABRC stock centers, this is in Arabidopsis plant, which is a model organisms in plant system. So here you can see we found three distinct abnormal phenotype. One is the defects in the seed morphology. So this is the mutant you can see. This is the wild type plant or normal seed. Here you can see there is a shrunken seeds, and it shows a reduced germination, significantly reduced germination, and it also significantly reduced viability. So the viability is compromised, germination is compromised, and there is a defect in the morphology. So that means SCIP31 may play a role to regulate this viability and seed germinations as well as the morphology or the development of the seed. We have confirmed this through the complementation assay, seed-specific overexpression lines and RNAi lines. And when we express SCIP31 ectopically, then you can see this mutant phenotype is restored. So this is the mutant. When we express them in this mutant background, you will see the restore the typical seed morphology, seed germination and viability like wild type. That means SCIP31 plays an important role in this particular traits. We have confirmed again by generating RNAi lines as well as seed-specific overexpression lines. We specifically express seed in this SCIP31 protein in a seed-specific manner, and we found that there is improved seed vigor and improved viability. So overall, all this genetic experiment, we can conclude that SCIP31 play a very positive role for seed maturation and seed vigor and viability. So now there could be two possibilities. One is either is due to the defects in the embryo, or seed development or seed maturation, or due to the defects upon storage, because we have analyzed all the germination and viability after storing. So what is the main cause of this defect? So we have actually analyzed germination, desiccation tolerance, phenotypic analysis throughout the seed development. This is the different stages of seed development. Here you can see this is the early stage of seed development. This is the S4, S5, S6, S7. And we found there is no defect in the early stage of seed development. So that means everything is normal like wild type. When you compare the mutant and the wild type background, so there is no defect. But the defect starts from the late seed maturation, like S7 stage. Here you can see that there is abnormal seed phenotype. There is a differences in the germination as well as viability. So premature browning, shrunken seed, and lower germination potential during the late seed maturation, not the early seed development stage. So till that, there is no problem at all. So now to understand the actual function of this SCIP31 protein, as I told you that what could be the possible reason, because as I told you that SCIP31 is basically an F-box protein. So if you can identify the target protein which is degraded through this pathway, can actually explain the phenotype. So to find out the interactive partner of the SCIP31 protein, we did a H2 hybrid library screening, and we found a very interesting protein as an interactive partner, JAZ, jasmonic acid gym domain protein. But this is very surprising because JAZ has nothing to do with the ABA hormone signaling so far. So what it does, so JAZ actually said, now introduce the JAZ, the interactive partner of the SCIP31 protein, or in other words, SCIP31 target this JAZ protein. So JAZ is basically a repressor protein of J signaling pathways. J is another hormone which is mostly involved in the insect resistance and biotic stress responses in the plant. So what it does actually, so JAZ actually interact with the MYC2 protein, which actually is required for J responsive genes expression, but this JAZ protein forms a complex with the MYC2 and replace the expression of the J responsive genes. So it's basically a repressor of the J signaling pathway. But another interesting observation was that COI1 is an F-box protein which is already target JAZ protein. So this is already known. This is very popular phenomenon in J signaling pathway. So this F-box protein COI1 already targets JAZ protein and degrades JAZ protein, and then allow MYC2 to do their job, and J responsive genes are undergoes or expressed. So if this JAZ protein is already targeted by the COI1 protein, another F-box protein, what does it do? What does our SCIP31 do? Because this is already targeted by the COI1 protein. And this interaction is J isolation dependent, because this interaction requires J isolation hormones. So then we wanted to know whether our interaction, the JAZ protein and SCIP31 interaction, require J isolations or not. So the next question, we wanted to know that whether interaction of SCIP31 with JAZ is coronation dependent or independent. So to know this, we actually did a Y2H analysis again in presence and absence of coronatin or J isolation. Here you can see that our interaction doesn't matter whether you apply coronatin or jasmonate isolation in the media or not, because we have supplemented media with this particular molecules. And we found that unlike COI1, because as I told you that COI1 requires coronatin molecule to interact. Here you can see if you don't use coronatin or jasmonic isolation, there is no interaction. However, in this case, you will see the interaction. So this interaction doesn't require, or you can say it's independent to the J isolation. And we have confirmed this interaction through biopsy and pull down assay. So then we again check, because we know the interaction. So whether it actually leads to the degradation of this JAZ protein or not. We have done several experiments. One is in vitro ubiquitination assay. Here you can see this in presence of SCIP31, JAZ undergoes ubiquitination, and this ubiquitination is essential for protein degradation, because this complex recognizes this ubiquitinated protein only. So what we can conclude here, that SCIP31 mediates ubiquitination of JAZ proteins and their degradation via the 26S proteasome pathway that we have confirmed through the cell-free degradation assay. Here you can see this protein is degraded, but when there is MG132, which is a proteasome inhibitor, then this protein becomes stable. So in this experiment, we can say that SCIP31 mediates JAZ protein and their degradation through the 26S proteasome pathway. So now we got two conclusions. One is SCIP31 positively regulates seed maturation, desiccation tolerance, and seed vigor through our genetic studies. Another way, we can find that this can mediate JAZ degradation, but whether this two phenomenon is interlinked or not, that we still don't know. So we wanted to know whether this SCIP31 positively regulates seed maturation, desiccation tolerance, seed vigor by mediating JAZ degradation or not. So this is another phenomenon, this is another phenomenon. So now I wanted to know whether this this seed maturation, desiccation tolerance of seed vigor is due to the degradation of the Jazz protein or not. So to confirm this, actually we have analyzed lot of mutants again. So this, if this is a positive regulator, then this should be the negative regulator, because it targets this protein and it degrades this protein. So if this overexpression lines is positively regulates seed maturation, desiccation tolerance, then this is the negative regulator of this one. So this overexpression line should behave like this SCIP31 mutant lines, because they act antagonistically to each other. And Jazz6 or knockout lines should behave like a SCIP31 overexpression lines. So that's what we did actually. So we found that these Jazz delta J overexpression lines mimic the phenotype of SCIP31 RNA lines. Here you can see. So this is the overexpression lines 1, 6 and 11. There is a abnormal phenotype. There is a reduction in the seed germination, reduction in the seed viability. There is a reduction in the seed germination. So this defects. So this Jazz6 actually mimics the phenotype of SCIP31 and RNA lines. So how Jazz protein negatively modulates seed maturation, seed vigor and viability? So meanwhile, there is another report came that this Jazz actually acts as a repressor of the AB signaling pathway. Earlier it was known as acts as a repressor of the J signaling pathway. But now we know that Jazz protein is actually interact with the ABI13 and ABI5, which is the master regulator of AB signaling pathway, and they actually repress the AB responsive gene expression. So then it explains our phenotype actually. So the Jazz protein interact to ABI-TFs and possibly repress their trans activation activity. So now the question is, are AB responsive genes down-regulated in the SCIP31 RNA and this overexpression line? So we have extensively analyzed the AB responsive genes in these overexpression lines and mutant lines, and here you can see that this all these AB responsive genes are down-regulated in SCIP31 RNA mutants and these overexpression lines, and upregulated in the SCIP31 overexpression and Jazz mutant. So now we conclude that the defect in seed maturation in these mutant lines, SCIP31 RNA mutant lines, or the Jazz overexpression line is due to the compromised AB signaling and downstream gene expression. So that explains our phenotype actually. We have also analyzed lot of things, like because ABA hormone regulates seed reserve accumulation, protective metabolites, ABA content, which actually required for the desiccation tolerance and seed vigor. But when there is in this mutant background, all are compromised. So there is a poor seed desiccation tolerance and seed vigor. While in the overexpression lines, these are improved because in this scenario, activation of ABA signaling happens. While in this scenario, because Jazz is there, so there is a repression of the ABA signaling. So in this case, because there is a SCIP31, they can target Jazz protein and they can induce the ABA signaling pathway. So this is the overall conclusion and the working model. So in the Jazz actually repress, that's what we have shown, ABI5 activity. Here you can see the Jazz acts as a repressor for the ABA signaling pathway. They interact with the ABI5. So that's why there is a compromised seed maturation and seed vigor, because ABI5 cannot act for the signaling. This scenario also happens during the seed germination, because during seed germination there should not be any ABA signaling pathway. While in case of seed dormancy or maturation, there is a lot of SCIP31 protein in the during maturation stage. So they can target this Jazz protein and let them degrade to the 26S pathway, and then this, if the Jazz degradation, then there is a ABI5 is free, they can do their job and they express the downstream genes, which is important for seed maturation and vigor. So these are my lab groups. So actually whatever work I have today discussed is all done by the Vishal and some other scholars as well. And I also acknowledge the funding of Department of Biotechnology, Government of India, and our extensively NIPGR core grant. Thank you. Thank you for your attention. Thank you. So is there any queries, questions? Yes, yes, Dheeraj.
Nice talk. So, what is the expression level of SCIP31 in recalcitrant seeds?
Oh,
and
that,
can you express it there and make it?
Yeah, that we have not checked. But in the other part of the story, like protein repairing enzyme PIMT, that is also another enzyme which is very essential to maintain vigor and viability for orthodox seed. So that particular enzyme is very less expressed in the recalcitrant seeds.
Right. Basically, the question is that.
Yeah.
Can you manipulate in such a way that recalcitrant seed can also become long-lived?
Yeah, but in a plant system, transformation is very difficult. It's not like animal systems. So there are certain plants that can be transformable like rice, Arabidopsis seeds, but Zekel seeds and seeds, they are not very susceptible for transformation. It's very difficult to transform them. Okay. Okay. Thank you, sir.
Associate of our in 2023. What do you want to say?
Good afternoon, everyone. Thank you, Professor Mondal, for introduction, and I thank Academy for giving me the opportunity to present my research work in front of the distinguished scientists of the country. So, the title of my talk is Amorphous Carbon Thin Film as an Emerging Electronic Material. So, all of you know that carbon has many allotropes which are classified according to the molecular hybridization of carbon-carbon bond, and but the amorphous carbons is a disordered form of carbon with a broad range of carbon-carbon bond and bond length and bond angle. Though the crystalline forms of the carbon like graphene, carbon nanotubes, they have attracted more attention of the researchers, but amorphous carbon has attracted less attention. So today I will show that how amorphous carbon can be used as a very good material in advanced electronics. Nowadays, foldable devices like foldable phone launched by Samsung and other companies, or some healthcare devices, they are becoming very popular. The key component of these devices is a foldable metal circuit. Nowadays, foldable metal circuits are conventionally prepared by encapsulating the metal circuit in between two thick polymer layers in top and bottom. Those polymer layers are called neutral plane. The role of this neutral plane is to compensate the stress developed while folding the metal circuit. But this method has many drawbacks. For example, as here the metal circuit is encapsulated between the thick polymer layers, so the heat developed cannot dissipate. So the durability of the circuit reduces. And secondly, the thickness of these two polymer layers must be exactly equal, which needs very precise fabrication process. And thirdly, in case of health caring devices, there the circuit must be touched with the skin so that it can receive the electrical signal from our body. But where this concept of neutral plane will not work. So I have developed a method where the metal circuits are covered with an anisotropically conducting amorphous carbon thin film, which can conduct the electricity in the vertical direction, but in the lateral direction it has limited electrical conductivity. It is conducting up to 1 micrometer distance, and beyond that it becomes insulating. Generally in the circuit board, the distance between the two adjacent metal lines is greater than 2 micrometer, and while folding the cracks developed has the size generally less than 1 micrometer. So when we cover the anisotropically conducting amorphous carbon film over the circuit, then it can exactly follow the complexity of the circuit, as well as it can connect the cracks developed while the folding. So you can see that this is the image of the micro LEDs are illuminating with the help of our hybrid amorphous carbon coated metal circuit at the extreme folding and crumpling condition. We have a granted patent on this, and now I will discuss how we synthesize this amorphous carbon thin film. Generally, graphene and other 2D materials, they are synthesized either by exfoliation or by CVD, either by top down or bottom up approach, but there are some problems, like those all the exfoliation is not very much scalable, so lack of scalability, and CVD needs some sophisticated instrumentation, and generally synthesis time is required very long, and they are very much substrate specific. So we have developed a synthesis method which is very easy, where we spin coat a precursor polymer solution over the whole 6-inch SiO2 Si wafer and just microwave it in household microwave for 1 minute, and then we get the amorphous carbon film over the whole wafer, and we can transfer that film over any desired substrate. We can precisely control the thickness ranging from 1 nanometer to 32 or 50 nanometer, and from the XPS we found that the film is nitrogen doped. We have another patent on this synthesis method, and when I transferred the thin film of different thickness over a conducting surface like ITO, then we found that up to 20 nanometer thickness of the film, the electrical conductivity of the film was exactly equal with the ITO. And when the thickness of the film gradually increased beyond 20 nanometer, then it gradually became insulating. And another experiment we did, we transferred the film over a gold circuit over PET substrate which is insulating, and there we have the gold lines situated at different distance ranging from 500 nanometer to 6 micrometer, and we measured the current at these points, and we found that when the distance between the gold lines is less than 1 micrometer, then the current level was very high and it is highly conducting, and when the distance is more than 2 micrometer, then the film becomes insulating. We also performed one conducting AFM study. There we transferred the amorphous carbon film over a gold pattern over the SiO2 wafer, and we measured the conducting AFM at the interface of gold and SiO2, and we compared the height map with the current map, where we found that the current was extended up to around 1.5 micrometer from the edge of the gold. This experiment also proves the anisotropic conducting behavior of the amorphous carbon film. This image shows that though cracks were formed in the gold circuit coated with amorphous carbon film, still the micro LED is illuminating with this, as the cracks are connected by the amorphous carbon film. From the AFM study, we found that the depth of the crack was 1 micrometer without any carbon coating, but with carbon coating the depth decreases to 200 nanometer. And this red line shows the stable electrical operation of the amorphous carbon coated gold metal circuit upon repeated outward, and this is for inward folding, but without any carbon coating the current level drastically fluctuates, you can see. And this amorphous carbon film has also outstanding protective capability. The silver nanowires are very useful material in the flexible electronics, but they are very much unstable. They get oxidized upon high temperature treatment or just exposure in the ambient condition for long time. But when we cover them with amorphous carbon thin film, they becomes very stable, and their morphology and their electrical conductivity remains same. We have also used our amorphous carbon thin film in the enhancement of a thin film oxide based transistor performance. This is the scheme of the thin film transistor. Here we incorporated the amorphous carbon thin film layer in between the SNO2 semiconductor layer and the lithium aluminum oxide dielectric layer, and we found tremendous improvement in the transistor performance due to the reduction of the interfacial trap states by the ultra smooth amorphous carbon incorporation. We found that the trap states reduced by 2 orders, the saturation mobility improved by 7 times, and on-off ratio improved by 3 times, 3 order. And you can see that with AFM we found that for the bare dielectric layer the roughness was around 0.9 nanometer, but in case of amorphous carbon coated dielectric layer the roughness reduced to 0.2 nanometer. So you can see that how smooth it became. And from the XPS also we found that this amorphous carbon film having nitrogen doping helps in the better growth of SNO2 layer. We can see the significant shift in the N1S region of nitrogen dopant of amorphous carbon film and the tin of SNO2 layer. Now I will discuss how amorphous carbon film can be used in deformable optoelectronic devices. Generally the conventional conductive transparent materials used in these deformable optoelectronic devices are metal oxides like ITO, FTO, or conductive polymers, graphene, carbon nanotubes, or metal nanowires like silver nanowires, or metal films. But they have many drawbacks, like some of them are very rigid. These has poor electrical conductivity, graphene and carbon nanotube. Metal nanowires, as I discussed, that they are poor environmentally stability, and metal film has poor transparency. So we have developed a ultra thin metal film which is highly conducting as well as very much transparent. So we found one interesting phenomena, that when we deposited silver, 10 nanometer of silver over bare SiO2 Si wafer, then we found that silver islands were formed which were disconnected from each other, so the surface was overall non-conducting. But when we deposited the same 10 nanometer of silver over amorphous carbon, then the islands get connected and it becomes conducting. The seed resistance became 20 ohm per square. And when to improve the conductivity more, what we did, we first deposited 1 nanometer of silver seed over the amorphous carbon, and then we deposited 9 nanometer of gold over that. Then the seed resistance further improved to 8 ohm per square. And from the XPS study, we found that the nitrogen doping of the amorphous carbon film helps in connection of these silver lines. That's why the surface is becoming more conducting. So this shows that how we prepared transparent, foldable and stretchable ultra thin gold film electrodes over polymer substrate. First we made the 1 nanometer of silver seed and then 9 nanometer of gold pattern over the amorphous carbon in full wafer. Then we coated with some polymer like PVDF or PMMA, and then we dipped it into the water, and by peeling off we get the gold pattern over the polymer layer, and so we got the gold pattern over the polymer layer which is chemically connected with the amorphous carbon thin film. So to make it more deformable, we transferred another layer of amorphous carbon thin film over it, and we got highly deformable gold ultra thin film which is hybrid with the amorphous carbon. And then we used that in fabrication of foldable perovskite light emitting diode. This is the scheme where we used our hybrid ultra thin gold film with amorphous carbon as a transparent electrode, and then P dot PSS as the whole injection layer, and then the perovskite PEO polymer composite as the emissive layer, and again as the cathode. And you can see that under extreme folding our PLED is illuminating very well. And we have also fabricated one biaxially stretchable alternating current electroluminescence device this is the scheme. This is our transparent conducting electrode, and here the emissive layer is ZNS copper PDMS composite. You can see even in twisted condition, in uniaxial stretching or biaxially stretching, our device is working very well. So in summary, I have demonstrated that we can synthesize amorphous carbon thin film, a very facile method, and in large area in 6-inch wafer scale. We can precisely control the thickness of the film, and we have utilized the anisotropic conductivity behavior of the amorphous carbon thin film to fabricate a foldable metal circuit. And this amorphous carbon thin film has also outstanding property as a protective layer to enhance the environmental stability of the easily oxidizable metal surface, and ultra smoothness of this amorphous carbon thin film was utilized to reduce the trap state, interfacial trap states between the semiconductor and dielectric layer of a transistor. And the nitrogen dopants of amorphous carbon film was utilized to fabricate a deformable ultra thin metal amorphous carbon hybrid thin film, which was used as a transparent conducting electrode in different display devices. And finally, I want to say that though the main focus of the scientist community is over the crystalline materials, graphene, carbon nanotube, there are still a lot of room in the amorphous carbon film that deserves more investigation. And these are some other research topics on which we are working: synthesis of epitaxial thin films, and synthesis of metal chalcogenides and their optoelectronic applications, surface modification of metal oxide nanoparticles, and biosensing application. I will be happy to collaborate with any of you. And now I like to thank my research grant agencies, my collaborators and research scholars, and thank you all very much for your kind attention. I will be happy to have any questions.
Thank you for this beautiful talk. Now it's open for questions, comments.
It's a very interesting amorphous form of carbon.
Thank you, sir.
Why is it conducting in a plane perpendicular to the film?
Yes, it has a, I will show this slide. Actually, this is very much dependent upon the synthesis procedure. If in our method, we are directly synthesizing the film over the SiO2 Si wafer. Here we spin coated the precursor solution, polymer solution over the wafer, and we microwaved it. And during microwave, abruptly within 10 seconds, the temperature of this substrate becomes 350 degrees centigrade. So very localized graphitization is happening in the adjacent layer at the substrate. So this is becoming very much conducting, and gradually as it is going up, the distance from the substrate is becoming higher, then the extent of graphitization is decreasing. So there is some gap. We can see that there is some gap. So electrical conduction is being limited in the lateral direction, but in the vertical direction it is being facilitated. And also it is very much thickness dependent.
Graphitic film is also not so conducting in a direction perpendicular because of the van der Waals. Yeah?
Yes, sir. It is very much thickness dependent also. We have shown that when it is very ultra thin, less than 20 nanometer, then it is vertically conducting, but gradually it is becoming insulating.
So it's an amorphous structure with partial crystal energy.
Yes, there is very small grains of graphites. That's why conductivity is different. Thank you, sir.
So I'm curious to know that for such amorphous materials,
Yes, sir.
is there some way you can get a little bit hint of the energy spectrum? Because of course, here there is no band structure. Because
Yes, yes.
So that's a major
Hmm.
doing any type of theory on this.
Yes.
But suppose if you do, let's say hypothetically, I don't know whether anyone done some artist type of things. What type of things you see? I'm curious to know that. It may be very nice question. I don't know about this.
Yes, sir. Actually, in amorphous carbon thin film, means it has broad range of carbon-carbon length, and bond angles are also very broad, and it is very much dependent on the synthesis procedure. And still, people are working. I didn't do any theoretical calculation for this, but it needs more research.
There is no way to get experimentally any idea about its energy spectrum or anything like that. Because I don't know even how to define that. But just is there a particular way of because of course you have talked about the various transport related measurements. More because in normal solid state we try to understand the transport basically from the band structure. So that is why I'm just trying to understand that whether in this case anything like that is possible or not.
Actually, sir, I don't have much idea about this because it is anisotropically conducting. So, in the vertical direction, there should not be any band gap. But like.
So there are crystalline material also which can have anisotropic conductivity. They are also we try to understand.
Yes, yes.
From the band structure, but
yes.
There is no such proof. That's why I'm trying to get is there any.
Yes, sir. That's why I told that more investigation is needed. Yes, sir.
Thank you for this lucid presentation. I only wanted to extend this question that was there previously. Are there any studies in the literature on let's say, a scanning tunneling electron picture of the surface, so that one gets some idea of the two layers? It's about 10 nanometer at the smallest one, so that one would like to get a greater idea as to the structure.
Yeah.
Is there anything in the literature?
Yes, there are some. Actually, before graphene came in the scientific community, there are many researches on the amorphous carbon, and before 2004. So there are some STM study reports also, but we did not show any. We did not do for our material. So there are some reports.
Thank
yes.
you. Yeah, I'm impressed by the simplicity of the procedure.
Yes, sir.
I'm just curious. I am guessing that you have probably done the initial experiments in a common household microwave oven.
Yes, yes.
So I'm curious. How reproducible is this?
Yes, it is very much reproducible. Actually, we did at least 5,000 times we did, and even class 10 student also can do this. Because it is very easy and very much reproducible.
No, but you control the time of this microwave radiation, or it must have required some amount of calibration.
Yes, and we also did in microwave reactor also to know the exact parameters. There also we have seen that we need 200 watt of microwave. And beyond that also amorphous carbon film will be formed, because in household we can control the power, not very precisely, but even we found that from 200 watt it starts carbonization. Below that it will not form, so prolonged time may be required. So it is very easy, sir. And
just one more.
yes.
You mentioned about something about your where you have tried this biosensing applications. Could you just elaborate?
Yeah, we biosensing, that is different. That is not with amorphous carbon thin film. That is with oxide materials, iron oxide. That is different thing from this. There we there I functionalized the surface of iron oxide nanocluster that is magnetically very much responsive, and I functionalized the surface with some half fragmented antibody, and it was zinc doped. So zinc doping helped to attach the antibodies over the surface, and then we sensed the particular bacteria corresponding to this antibody, and we detected the bacteria from the milk using that antibody functionalized iron oxide nanocluster.
Stable and
yes, very much reproducible.
Any more questions? One more. Okay, last question.
It's an interesting topic.
Thank you.
Ma'am, is there any other material or alternative material instead of amorphous carbon
For which application?
for electronic devices?
Yes, there are many. Actually, mostly people are working with graphene and 2D materials, like metal chalcogenides are also very good candidate, and carbon nanotube, different, as I mentioned, different crystalline allotropes of the carbon are taking the main focus. Yes, there are many.
So what made you to study about only the amorphous carbon?
Actually, this is very easy, as I discussed that we got, actually, frankly speaking, we were trying to make some other material and we got this by God's grace. And then it became a blessing for us. And now we are investigating that it has many unknown properties which are doing excellent in different applications.
Okay.
Thank you.
With that, let's thanks again, Mona Lisa, for
Thank you.
And I hand over the mic.
Thank you so much, Professor Mondal, for conducting this so nicely. So I know that we don't want these talks to end, right? We'd love to have another half a day or another day, but I guess all good things have to come to an end. So we will now, after a few remarks, we will break for lunch, and you can eat as much as you want for as long as you want, then you don't have to come back to... So on behalf of the Academy, I would like to thank, of course, Mr. Mahesh Chandra and his team for all the wonderful and excellent arrangements, our colleagues from Current Science who have also come in and helped us, and of course the team in the auditorium who have been so efficient. Thank you so much with all the... Yes. Thanks to everybody for really, and my colleagues in the Secretariat, all the people who helped with chairing the sessions, and of course all of you for being a wonderful audience. I'd like to say that the annual meeting of the Academy this year is going to be very special because it will be the 90th year of the establishment of the Academy. It will be held on the 7th, 8th, 9th of November in Bhubaneswar. So possibly it's going to be at nicer Bhubaneswar. So I invite all of you to come there, and I'm sure we will have a very wonderful time. So any other comments, Umesh?
Please join me in thanking